Endeavour Houston for the PMC. Do you guys prefer air to ground 1 or 2?
Yeah, air to ground 1's fine.
Okay, we'll put it in work.
Houston Endeavour for the ET umbilical well images.
Go ahead.
Hey, Mass, I'm done with the procedure, and the images are on the WLES machine on the C drive.
Copy, Drew. We'll go ahead and get those, and we're going to privatize air to ground 1. So the next voice you'll hear on air to ground 1 will be the surgeon's voice.
Copy.
Endeavour Houston, we're back up with you, normal comm, and have some words for you on the upcoming digital playback.
Go ahead.
Yeah, apparently there were some cutouts on the playback of the external tank video. What we'd like you to do is to start that again from the beginning, run it in its entirety, and just to remind you, the times we're going to pick up here are 6:09 to 6:21.
Okay, 6:09 to 6:21. We'll play the whole thing again.
Thanks a lot.
Capcom Mike Massimino there talking with the crew about the video they were sending down earlier of the external tank after it had separated from Space Shuttle Endeavour. Their next opportunity to send more video down is coming up in a little less than 20 minutes now. The crew currently is just a little over an hour away before they're scheduled to begin their sleep period, wrapping up their first day in space for the STS-134 mission.
Endeavour Houston for switch throw on C3 for the left ohms accumulator.
Work, go ahead.
Yeah, we'd like to repress the left ohms accumulator so we don't get any alarms while you guys are sleeping. So on C3, we'd like you to take the left ohms engine to the arm for 10 seconds and then off. And that's the arm press. Arm press for 10 seconds.
Copy, left ohms to arm for 10 seconds and then OFF.
Yeah, just to be clear, arm press for 10 seconds and then off.
Okay, arm press for 10 seconds. We had it in arm for a couple seconds. Now it's going to be in arm press for 10 seconds.
Thanks.
Hey, Houston, that's complete on the left ohms engine.
Copy, thanks.
With their bedtime coming up just a little over an hour away now, the crew of Space Shuttle Endeavour is going through their pre-sleep activities. That's some of the work that gets themselves and the shuttle ready for a night on orbit, including that conversation you just heard between Mike Massimino and the crew, asking them to reset a limit on one of the orbital maneuvering system pressures to make sure that it doesn't sound any alarms and wake them up during the night. Endeavour is currently 202 miles above the North Pacific Ocean, having just crossed over Australia, heading towards the western coast of Canada. The crew is scheduled to begin their sleep period at 2:56 p.m. Central Time, and then they'll actually wake up later tonight at 10:56 p.m. Central Time to start their second day in space. That, of course, is going to be focusing on the usual surveys of the shuttle's heat shield using the orbiter boom sensor system attached to the station's robotic arm. Although this survey will be standard, the one that they'll perform before they come home will be a little different than usual because they are going to be leaving that orbiter boom sensor system at the International Space Station, where it can be used as needed as an extension to the space station's robotic arm. That transfer will occur on one of the shuttle's 4 spacewalks that are scheduled to be performed during this mission. The first spacewalk will be coming up on Friday, and there will be a second on Sunday. The final 2 will be on Flight Day 10, which is May 25th, and Flight Day 12, which is May 27th. Normally, the late inspection occurs after the space shuttle has undocked from the International Space Station, but since they're going to be leaving that orbiter boom sensor system behind, the late inspection will actually occur on May 26, Flight Day 11, the day before that final spacewalk, which is when the orbiter boom sensor system will be transferred to the International Space Station. In addition to about 50 extra feet of reach for the space shuttle's robotic arm, it also provides the shuttle with a special system of cameras that allow them, teams on the ground, to get an up-close view of the shuttle's heat shield, making sure it didn't have any damage during today's launch. Those cameras won't be used by the International Space Station crew. It'll just provide some extra reach for the space shuttle's robotic arm, space station's robotic arm. that has been used before on a spacewalk to repair a tear to one of the station's solar array wings. On its own, the space station robotic arm didn't have quite enough reach to get out to that solar array wing, but with the shuttle there, it was able to make use of the orbiter boom to get a little bit more reach. And it'll actually be able to get even more reach in the future. At the moment, the space station robotic arm is only able to grab the orbiter boom sensor system in the center of the boom. But the spacewalkers are going to add some hardware that will allow it to grab onto the end as well, which will double the full amount of reach it gets from that boom.
Denver, Houston, for playback, can you check to see if the MUX is on?
Yeah, affirmative, Houston. The MUX is on.
Copy, MUX on. Thank you.
Hey, and Mike, we're complete with everything in the flight plan with the exception of in the easy activities, we're going to do the CSA CP battery change out, check out, and zero calibration. If you can remind us to do it tomorrow.
Copy, Mark, and we will put that in as a reminder for tomorrow. Denver, Houston, Mark, one item we're still looking for down here is the mid-deck status check, if you have that.
Endeavour's crew reporting that they are just about done with all the activities on their to-do list for the day. Everything that was scheduled for their first day in orbit.
That in work, Houston.
Thanks.
Just got a quick reminder that the team here on the ground would like what's called a mid-deck status check.
On a forward MET timer, the one on 03, it currently says 0 days, 2 hours, 12 minutes, 46 seconds. So the hours are off by 4 hours. We went to test. GMT is correct, I believe, and can't figure out how to correct that. I don't think it's the digit thing that we're talking about pre-flight, but if you could just think about it overnight, it'd be nice if we could correct it.
We copy, Mark. We'll see what we can do about that. We'll see what we can do on this shift and then hand it over to the planning shift, and hopefully we'll have something for you in the morning.
All right, thank you. And Houston Endeavour for downlink.
Go ahead.
Hey, Mike, I'm ready to press play again if you guys are ready to receive.
Greg, we're going to call you back. We have a handover coming. Stand by.
Copy.
Endeavour Houston for playback. Greg, we're ready for you to hit play anytime.
Okay, Mike. Stand by. Here it comes.
Thanks.
Should be getting more of that video of the external tank momentarily. We saw some of that earlier before the crew ran out of video downlink capability.
Okay, I've got 4 green lights. You should be getting it now.
Video was taken after Endeavour's 7:56 a.m. Central Time launch. And we'll show the external tank that provided fuel to the main engines as it was making its way into orbit. Video was actually shot by Mission Specialist Mike Fink. He was in charge of shooting that video during ascent, and his crewmate, Mission Specialist Drew Foystel, was in charge of taking still photos of the tank. All of that will be added to the collection of imagery that will be studied here on the ground by experts looking for any signs of anything that might have hurt the shuttle's heat shield during launch. More information, of course, will be added to that tomorrow during the inspection of the shuttle's heat shield.
Endeavour Houston for the playback in MUX, we'd like you to check something.
Okay.
Yeah, Greg, unfortunately, we're not seeing anything down here. If you can check on the MUX, you're getting a data light and an FO OK.
Yeah, I've got fiber optic okay. I got a good data light. Both are green. No other lights on channel 2. One question, on the cue card, it showed the RX receive channel 2 input, and I was questioning that. Should it be TX or RX? Maybe that's the issue.
We'll check. Hey, Greg, that should be RX. Is that what you have?
Yeah, I have RX.
Yeah,
and I've got 4 good green lights on the MPC. Both sides of the MUX is powered up.
Yeah, Greg, we're talking about it down here. We're still not getting anything, but we'll check and see what we got down here.
Copy.
Team here on the ground trying to troubleshoot issue with getting the video down. Not sure what would have changed between this time and the last time when we were able to get some of that video before the window to downlink it ran out. But we'll be working on that and hopefully seeing that soon.
Endeavour Houston for the downlink. Endeavour Houston for downlink.
Go ahead, Mike.
Yeah, Greg, sorry, it just didn't seem to work this last time. We apologize for making you go through the whole thing twice. We did get a lot of footage the first attempt. I guess with some pieces missing. So they're going to take a look at what you gave us the first attempt overnight. They'll take a look at that. Apologize for making you do it twice. But if you don't mind, if you can keep that tape handy, we might ask you to do it again tomorrow. So please keep the tape handy, and we'll see if we can figure out what went wrong on that second attempt, and hopefully have a better plan for you tomorrow.
Okay, Mike, I also wanted to downlink some flight day highlights as well, so if we can troubleshoot a little further, I wouldn't mind doing that. One suggestion is to power off the right side of the MUX and power it back up again, because when I did send it down before, it took priority for MPC, but I didn't have the VTR off, so I'm just wondering if powering down the right side of the MUX and back up again might reset it.
Endeavour Houston for downlink.
Go ahead.
Hey, Greg, we really like your suggestion. Let's put that in work. And just so you know, we have another opportunity for downlink at 6040.
Copy.
The team here on the ground was going to go ahead and let the crew get on with their pre-sleep work. They've got their bedtime essentially coming up in about 35 minutes, but the crew said that they wanted to get some flight day highlight videos down as well, and so they were willing to keep troubleshooting the problem they're seeing with the camera. So they'll keep trying that, and then they have another opportunity to send video down in about 15 minutes.
Powered off and powered on the right side of the MUX. The video is playing right now. I have fiber optic okay and data light okay, both green on channel 2. And it's playing, and I see 4 lights on the MPC.
Endeavour Houston for Greg. That all sounds good. Let's try it at 640. We would like to see your flight day highlights, but our priority down here would be to get the tank video first. If you can play the tank video in its entirety, we'll try that. Hopefully we'll get that at 640, and then you can follow that up with flight day highlights.
Okay, very good. We're ready for that. Talk to you again at 640.
And Greg, just so you know, that pass that starts at 640 will be 10 minutes.
Okay, and what's the next one after that?
Greg, to answer your question, the next pass after that will be at 0710. That's a long pass. That goes on to 0804.
Okay, that's good. Thank you. And Houston Endeavour for Photo TV1.
Go ahead.
Okay, Mike, just want to report, I think we have everything else set up in Photo TV1 except the WVS checkout on page SS-1-10. We'll just plan on doing that tomorrow.
Copy. We'll hold the WVS checkout until tomorrow.
Okay, good copy. Houston Endeavour for mid-deck status check.
Go ahead for the status check.
Everything looks in great shape. Glacier at 1915 at minus 35 Celsius. CGBA 1920, temperature of 22.5.
Grazie, Roberto. Those are good temperatures. We copy all. Thanks.
Prego.
Mission Specialist Roberto Vitoli there, reporting down what's called the mid-deck status check, just a daily check that the crew performs for the team here on the ground, letting them know whether the conditions are comfortable for the astronauts on the mid-deck, and also just double-checking to make sure that pockets of CO2 aren't collecting. That would require special efforts to make sure that ventilation is good down there. That's one of the last things on the crew's timeline for the day. Only thing left, I believe, is now the video that the crew is hoping to send down. Again, the next chance they'll have to do that's coming up in 10 minutes now. And they'll have 10 minutes of time, a window of 10 minutes to get some of the video down, and then there will be another one about 20 minutes after that. The crew is currently scheduled to begin their sleep period in 30 minutes now.
Endeavour Houston for playback. We see good indications down here. You go to hit play and start the playback anytime.
Shuttle's moved back into...
Hey, Mass, just hit play. Let me know if you guys see something showing up.
Okay, we're looking. And we got it. Looks great. Thanks.
Bet.
Window for downlink video has opened up again, and so now we're seeing some more of that video of the external tank shot by Mike Fink after Endeavour's orbit earlier this morning.
Okay, Mass, go ahead.
All right. One thing is, in your pre-sleep config, page 3-4, step 6, lists a few things to check the power off on. For your TV monitor power control unit, we would like you to leave that on overnight. How copy?
Okay, leave on the TV power control unit. We've got a note here that says "and in command."
That sounds even better. Leave it on and in command. It's perfect.
Okay, we'll do that.
All right. Next thing is, a little bit ago I told Mark that there was a maneuver planned while you guys were sleeping. That was going to be controlled from the ground. And I told him we weren't going to do that. And now apparently we might do that. We're not really sure. So you might be maneuvering this evening while you're sleeping. We can control that from the ground. There's no action for you. But just if you saw something happening, we don't want you to be surprised. So we're not sure. You may or may not have a maneuver control from the ground this evening.
Okay, Mass, we got that.
And then, finally, we have some words from your families. They wanted us to let you know that they had a great time at the launch. It was a great launch. It was very, very nice. They appreciate everything you did for them and wish you all the best of luck in your flight. They had a great time, and they'll be coming back home soon.
Well, that's fantastic, Mass. Thanks for the kind and thoughtful words. We wish them all the best as well and a safe return back, and we're happy that our friends and family were all there to see us launch off into the sunrise there.
Copy. We'll do that. You guys have a good evening and a great flight.
Thanks.
This again is video recorded earlier today obviously after the external tank separated from Space Shuttle Endeavour, about 8 minutes into its mission. Video was recorded by Mike Fink and is being sent down to the teams on the ground for a closer look to make sure, to gather any data that they can from it, and in particular make sure that there aren't any indications of anything that might have happened that would have hurt Endeavour's heat shield on its climb into orbit.
Houston Endeavour for MPC downlink.
Go ahead.
How did that work, Mike?
That was great, Greg, and if you don't mind, we'd love to see your flight day highlights if you can send those down.
Okay, how much time do we have?
2 minutes right now.
Okay, it might need some editing, but it's coming down. I got 4 green lights. This is 8 minutes, unfortunately, so I think we'll have to pause it.
Okay, we're seeing it now. We see you on the big screen, and we've got about another minute and a half, and then maybe we can pick it up another time.
Okay, sounds good.
Hey, Drew.
Hey, Taz.
There you are.
Yeah, thanks.
Back in space.
We're back in black, buddy. It's nice to be back. That was one heck of a ride.
Yeah, it was awesome.
Fantastic, and it's good to be here. We're just getting reconfigured here for the cameras, and we're gonna get busy.
All right.
Now it's recording.
Okay.
You ready for the almost 2 burn, Taz?
Ready for those 2 more burn.
Are you sure? I'm not sure I
I'm
am.
getting used to this again.
I'm not sure I'm
Greg,
ready.
it's coming down great. It's being played on our screen here. We can hear it.
Leg brace going here.
We are going to have an LOS in about 45 seconds, and then we're not going to pick it up again until about 7 minutes from now.
Can we get a shot of you?
Yeah, we're ready.
Okay, copy. Let me know when to pause.
All right.
Watch out for that boot.
Where is that? All right.
We're gonna see if the boot can make it. It's like a 2. Is it a 2-minute burn?
Yeah, 2-minute burn.
Okay, Greg, let's take a pause now.
It's gonna definitely back to the trampoline.
Yeah.
Okay, copy. You say there's going to be a little bit more in a few minutes?
We'll get you back in about 7 minutes, and then we pick up we pick it up again at 7:10.
Short preview there of what's to come in flight day highlights. Just a minute or so of what the crew has reported. They have about 8 minutes in all, they said, and hope to send down some more in the next window, which is coming up in about 20 minutes. Meanwhile, the crew is in their pre-sleep period, just about 11 more minutes left of that before they're technically scheduled to start their sleep period, ending their first day on orbit for the STS-134 mission. They'll be getting their wake-up call to start their second day in orbit at 10:56 p.m. Central Time tonight. TD.
Terry Houston for a quick tag up.
ahead, Houston.
Mark, we see bedtime in about 4 minutes. That next HD downlink is coming at us in about 14 minutes. That's into your sleep period. Not sure if you want to bother with that, but that downlink time is coming up, and we understand it's in your sleep period. We can maybe try to get it down tomorrow, if you prefer. And then we got everything we need. Just to let you know, we got everything we need from the tank survey. We appreciate that. So it's just if you wanted to, whatever you want to do with the crew choice stuff. And then I had some questions for Drew on the storm setup when he's ready.
Okay, yeah, we will send that video down tonight. It'll be the last thing we do before going to bed. And go ahead with the questions for Drew.
Okay, thanks. I look forward to seeing your video. And Drew, we noticed you got ahead on the storm setup with the PGSC setup. We're wondering, did you do anything with the standard switch panel switches?
Negative. All I did was made all the connections for the PGSC hardware and started up the laptop to verify that it was on the net. Otherwise, no other switches were thrown and no software was started on the machine.
That's perfect, Drew. That's actually what we wanted to hear. That's a perfect overnight config for that thing. We appreciate all your good work and all your crewmates doing such a great job. Congratulations, Mark, to you and the crew for getting to orbit and doing a great job on flight day one. We look forward to working with you guys tomorrow.
Thanks, Mike. We'll talk to you tomorrow, but just call us and remind us about the when you're ready for the downlink. We'll do that and as the last thing.
Certainly. Once we get it all set to go, we'll tell you when to push play.
Coming up next on NASA TV, we're going to go away from mission coverage for a few minutes for a video file that's going to include a crew news conference from the new members of the Expedition 28 crew that are getting ready to launch. Their launch is going to be on June 7th on the Soyuz TMA-02M, and it's going to be taking Mike Possum, Sergei Volkov, and Satoshi Furukawa up to the International Space Station to join Ron Garan, Andrei Borisenko, and Alexander Samokutuyayev on the International Space Station. Dmitry Kondrachev, Paolo Nespoli, and Katie Coleman, who are currently at the station, are getting ready. This is Mission Control Houston. That plan to go to the video file at the top of the hour is being delayed just a few minutes, but we expect to have that momentarily. Again, it's going to feature members of the Expedition 28 crew that are going to be making their way to the station on June 7th. That should be coming up in just the next few minutes. And we are now ready to go to that video file. Again, this is going to be featuring Expedition 28 crew members Mike Fossum, Sergei Volkov, and Satoshi Furukawa in their crew news conference, and then also get to see them visiting Red Square in Russia. That's coming up next on NASA TV, and this is Mission Control Houston.
Hello. So today we have already undergone the agency committee that determines crew readiness. At the end of past week, on Thursday, the crew has undergone integrated sims. I understand that many of you were present at those simulations, and I know that the crew has passed all the tests. The grade is excellent. And for today's procedure for the agency, where there are various representatives present of various agencies and organizations, everybody had signed the protocol and concluded that, or stated that, the crew has completed their training, and the crew is admitted to the completion of training. And introductory word, that's enough for introduction. If anybody has any questions, or if no questions, let's get started. Who has questions? Were you able to train for all the contingency situations when you were taking your tests? During our training, in general, we normally practice, during our sims, we practice actions in design contingency situations, which means that we train for what has been discovered on the ground. And so those are the anomalies that we simulate. Of course, the off-nominal situations that are inadvertent and unpredictable are impossible to train for. So we could say that if we did train for them, it was not completely. When we were flying our expedition 3 years ago, then there was a pump that failed, and that was not a design contingency situation. And the restroom failed, and we were without the restroom for about a month. No, don't tell them that, because they'll say that they were without any restroom for a long time. Here, usually, how do we deal with that? Usually, we use our smarts, and we use whatever is available to us. At least for the shuttle, we had already nominal parts. We put it together, and I'm going to add a little bit, Sergey, that although the training goes according to the nominal program and the design contingency situations, but some of nominal situations are also being simulated. And at the stage of training, the crew is thinking about what might happen. If you look at the program of training, and we have analyzed that program, the preparation for that nominal program takes about 20% of the training, and 80% realistically takes to train for what is to be done if something goes wrong. So as far as the design situations or off-nominal situations are concerned that are not design situations, the crew must be ready to mitigate those situations. And also, I remember now that, of course, during the spacewalk of our first colleague, we had to disassemble pyrobolts of our Soyuz, and nobody could have ever thought that the crew would have to go out and work on our own vehicle without coming back to the Earth. So we had to do some modifications in order to get back safely to Earth. And it's hard to work in space anyway, especially disassemble something there. And in flight, and also Sergei Konstantinovich visited us. Deputy General Designer visited and observed the training and told us how to work there and what to do there. And also, by the way, to continue as far as training is concerned, those are questions which people are not ready to ask. Speaking of training, certain skills are formed. It's not just that a flight program is simulated, but during the training, the skill that is formed can also be used for various situations, not necessarily for nominal flight itself. And last time what we had to do, the skill that has been created, the overall generic skill with working with the station came in very handy. More questions?
Television. Mr. Foss and Michael, can you compare preparation to a Soyuz flight with the shuttle preparation? The first question, a question to Mr. Furukawa. Can you please, you're a medical specialist, does it help you in your scientific program, and what is your scientific program on board the International Space Station?
Okay, I'll start out. The preparation for a space shuttle mission is about a year in duration. You're assigned about a year out with intensive training for about 8 months. We were assigned to this flight about 2.5 years before. I was assigned 2.5 years before. It's a much longer road, and you're traveling around the world, training in the U.S., in Russia a lot, in Japan, in Germany, in Canada, and so it's a long road. It's a great thing though to work with some of the finest people around the world in the space programs, and it's been a great experience for me.
Okay. As a medical doctor, I am interested in science, especially life science. Is it okay? Okay. And I would like to explain and inform the importance and the significance of experiments on board the station. During our mission, I'm conducting plant experiment using cucumbers. And that auxin is a plant hormone, and that its distribution affects the generation of and the growth of plants. And in this experiment, we concentrate on the the auxin-related proteins, so that we can determine how the auxin works. Yeah. And it will benefit people all over the world, for example, in the future space plant. And as a medical doctor, if something medical emergency happens on board the station, I'd be happy to, I hope that kind of things does not happen, but if it does happen, I'd be happy to help fellow crew members.
What kind of talisman or good luck charm are you going to have on your flight? A major portion of experiments that is conducted on board is a continuation of that scientific program that we have started that we've been doing 3 years ago, and during our EVA with Alexander Samakutyaev, we're going to maintain communication. We're going to do the appropriate work with that hardware, and if everything is successful, it will allow us to process large volumes of information. Unfortunately, we can't do it now. Otherwise, naturally, there will be human research experiments, typology. To decipher those experiments probably doesn't make any sense because it will take a long time. So we're going to continue our experiments, Saner, Hurricane, Uragan, and also experiments devoted to the studies of the waters of the world ocean. And those will be experiments directed towards mitigating or fighting the elemental disasters. Also, there will be studies, atmospheric studies, and maybe we'll do a certain analysis which will improve the ability to forecast elemental disasters. All of those regions are photographed, are studied, and SANER, that is to aid our fleet so that we could always have fresh fish. Also, the experiments are continuing on the studies of radiation background around the Earth and the effect of radiation, both solar radiation and other radiation, both on the people that are on the station and also on the station itself, on the materials. Alexander and I are going to install a new series of specimens which will be exposed on the surface of the station. So these are the major experiments that will be conducted. This last time I had a little doggy. No, I had a bat, a soft bat flying last time. And right now, Yegor gave me, as a child, he watches movies, and so he's interested in the popular characters of modern cartoons. Okay, if I may, it's from a cartoon Smishanic, a character from a cartoon. You have undergone successful training, and you have passed all the tests with a great excellent. What is your mood? What is your feeling when you're going to Baikonur? Good. Because of my excellent instructors, we are ready for flight. And I am proud that I am a member of a wonderful international crew. And this is a great honor for me. Spaceflight is. And especially because it's close to the 50th anniversary of the first flight of man in space. And I'm hoping that in the future, the international cooperation will grow.
Question, Mr. Furukawa. What is your updated information to have a conversation with people in Tohoku who are suffering the earthquake? Which date it can be, and what kind of message you'd like to send to the people in Tohoku?
Okay. Okay. I requested that I have some meeting with those that suffered from earthquake in Tohoku area, and it is still under coordination. So at this point, I cannot clarify the date.
Stephanie Stoll of NASA TV for Mike Awesome. What is your level of excitement as you head into your final month of training before you leave for Kazakhstan space?
Hey, Stephanie, that's a great question. It's been a long road getting here, and it's been a hard road getting here. We've gone through a lot. We've trained really hard together. I've become like brothers with my crewmates, and it's an exciting thing. So we're ready for the next step as we have completed our training in Star City with the commissions last week. That was a great step, and now we move forward to Baikonur in next week, where we complete the final fit checks and preparations and trainings there. So we're excited about it. It's a long road, but now most of that hard work is on the ground is behind us, and we're looking forward to the hard work ahead in space.
And a follow-up to that, today we're expecting to launch the Space Shuttle Endeavour. Do you have any thoughts as we head into that final historic mission?
We're keeping track of Endeavour's progress through the countdown and the progress through the night as they began, the rotation and the fueling and everything. So we're keeping track of the guys, and we're cheering them on. And I've flown twice with Mark, and I can't believe he's going to space without me. I gave him a hard time and told him if he waited too long, we would meet in space again.
a question to continue the subject of earthquake. Is there such a special program of Japanese or Russian astronauts and cosmonauts in support of that? Maybe there are capabilities to see what happens in Japan from onboard the ISS. Is it possible to forecast tsunami?
Yes. Okay. There is, of course, from International Space Station, astronauts and cosmonauts can observe the Earth and can take photographs of the area. And so far, to my best knowledge, there is no new program or related to earthquakes.
I'm going to add, indeed, right now there is no program to forecast earthquakes or track down the movement of tsunami. And unfortunately, earthquakes, too, what we could help with is to do photographs, and of course photographs are a consequence, and if there is a good resolution and a good area could be covered. Unfortunately, nowadays, or in this particular case, we work with the evaluation of the results of the consequences, but unfortunately we're unable to forecast extreme situations. I would like to add also, indeed, you can take pictures of what has already happened. So to speak of the fact that the picture may help forecast is not quite correct. During my previous flight, there was Katrina hurricane, which has done serious damage in the south of the United States. The the city of New Orleans suffered greatly. We saw a huge cloud, and meteorological satellites may show photography with greater resolution. But the results that we have, if we were to talk about earthquakes, then if you were to look at it from on board the ISS, you can't really see much, but indirectly one might be able to predict the signs, the symptoms of an earthquake, not be able to predict the development of earthquake or tsunami because it may be in quite a different area. It may be conditioned by the geomagnetic properties of the Earth. And right now, there are scientific experiments that are ongoing on that subject, and data collection is ongoing, and it's not about forecasting an earthquake. The only thing where we could participate in forecasting catastrophes is that the ice caps are photographed continuously. And if you remember, there were pictures that were dropped of 5 days ahead of time, where the scientists were able to see that the ice cap was going to descend. And right now, it's clear that it happened unexpectedly because of the procedural complications. But right now you can see our main task is photography of ice caps and monitoring that is continuing the Kolka ice cap, and the process of collecting the data and tracking down the motion of the ice caps. This is all in progress. Also, as far as a blog is concerned, we're communicating about the blog with Roscosmos representatives, and you're probably aware of that. Right now, we're just in the process of analyzing what is more interesting, perhaps. and maybe not too costly as far as work hours are concerned. So we will have something for sure. Thank you. Is it the easiest way to learn what you're going to go through before flight is to ask your colleagues, to consult them, exchange their opinions? Sergei is an outstanding commander. A great ISS commander. This is my first flight. But I think that the variety is important, both as far as international representation and experience. And we are that way, both as a crew and also we are well synchronized as a crew. And I'm in the process of studying it further. We're working together very well.
To share their experience with you. What kind of questions did you ask them?
Okay, I'll speak now.
Yes, yes.
For example, what was different from what you thought from taking training on the ground?
Well, I asked a question, what were the difference between the training on the ground and the real flight? The thing is that as soon as we're together, sooner or later, of course we don't always talk about work. We have other topics to discuss, but as a rule, the analysis of any simulation during the debrief, we always pay attention at those things which are impossible to simulate. So the data exchange is ongoing continuously, uninterruptedly. And it's not just the main crew, but the backup crew participates. And Satoshi is worried about information overload. We have very good relationship among ourselves, and usually, as a rule, there are certain fine points that come up which you can't remember immediately, and the process of formation of information exchange, as it happened 10 years ago, where my commander shared his experience with me, not only during training, but also during travel, and this is all ongoing. So, what about the everyday life moments that you cannot simulate? This is the main thing, of course, because during the work on the station, instructors train us both here and in Houston, but the quotidian details that are easier to bear are less costly to be trained for. The simplest one is, let's see, there's certain details. Let's say, how do you prepare food? What sort of things are you going to encounter? Any travel, any trip, any communication, or any storytelling when the cosmonauts and astronauts get together and they reminisce about their flights. And so this sort of thing, even though it's not a formal lesson, but such history, such exchange of information is extremely useful, especially because it has been heard not as a part of an official lesson, but because you've heard it from a real person to whom it occurred in reality a couple of years ago in flight. And so I've been telling such things to Sergey. I'm sure Sergey does the same. Also, when we were training for flight with Oleg and during the traditional meeting with the medical specialists who participate also in planning as far as training is concerned, let's say I didn't have this information that I had to wait after eating a certain time before I do some physical training. And on board, it turned out that it was not quite comfortable or convenient to do the physical exercise right away after a meal. And if you do it against that advice and you're on a treadmill, you can feel that piece of bread jumping with you on the treadmill. So these are those little things which cannot be felt on the ground. Sergey, you are a student of the Russian Academy, and are you planning on taking an exam as a part of your study? Yes, I don't want to miss the exams that are due, and I believe that I will make sure that I'll take the necessary tests. I already have a plan, a curriculum of the next set of exams that I have to pass. I got the email. So it'll take me a long time to answer all the questions. Sergey, a question for you and the crew. The events that you will be responsible for in flight, if those are minor dates, minor events, if the ground doesn't remind us, then we won't be able to celebrate them. But let's say, remind us that today's been 50 days, or next time it's going to be 100 days. If the ground sends us reminders, then we will be celebrating certain minor events. But otherwise, we're only going to have 3 additional state holidays. One of them is a Russian holiday, June 12th, and 4th of July is the American holiday, and in September there is a certain holiday as well. And the final question.
This time, one of the things we will celebrate during this flight is we will be there for the final space shuttle flight of Atlantis on STS-135. We look forward to seeing Chris Ferguson and his crew. It will be an exciting time. It will also be a sad time as the shuttle completes its 30 years of mission.
Hello, dear Sergey, Alexander, dear Oleg Dmitrievich. It happened so that your first flight coincided with our anniversary and of our cosmonautics, and this particular new flight is also happens to be also coincide with an anniversary. So if you have any other questions for the backup crew, we could accept that. Well, I have a question. My signal is Eridan, which is a constellation which starts in the north hemisphere and ends in the southern one. Our signal is Antares because there is a tradition to select it from the constellation of bright stars. And my children's names start with the letter A. That's why I have chosen the brightest constellation. It's orange is called Antares, and that's where it comes from. The question was, did you call and ask? Yes. Because of him, I have experienced cosmonauts Vladimir Titov and Sergei Leonov, and of course Sergei Krikalev. And nevertheless, I called him as my commander and instructor. And I called my father, yes. I told him what goes on board, what is expected on board, and then he would tell me that I don't work hard enough, that I have to work better. So he was trying to teach me as a professional would teach his disciple. I took advantage of the fact that I know Sergei Arkhipevich personally. I have called him, and it was great to talk to him, and I shared my observations with him, which were very useful in terms of how the information is transmitted. And it was, he has such a great memory that he knows exactly what to recommend, what advice to give. And what did you ask your father? At first I complained to him how hard it is to do physical exercises on board. And he said it was hard for him as well, and that he was forced to do that. And this is how he was able to maintain his health. And so that was one of the first discoveries that we were talking about earlier, how hard it was to do physical exercises on board. It was a great press conference. Thank you, everyone, for your questions. I think it was interesting to everyone. And the traditional picture, photos, and if anybody has any personal questions, go ahead. The crew had a busy day today.
Еще ответьте, пожалуйста, немножко. Все, есть, окей. Руки пожать. Сейчас пожать. Да. Все, спасибо всем. До свидания.
No, there's a lot of traditions associated with the Russian program and stuff. So we finished the big commissions last week, Thursday and Friday. Really big deal. We come in and we stand at attention in front of the board of the commission, and we report in the morning. And I did that the first day as the commander for the space station. And then we go through the full day of jumping through the hoops and running the systems and handling the emergencies and stuff. And at the end of the day, we sit down with the commission, and they've been watching every detail of what we've been doing for the entire day, and then they pick us apart.
I remember 6 months ago when you were here, and you told me that, it wasn't your time, but now it's your time, and what does it feel like to finally be this close to launch?
It's really unbelievable. It's such a long road, and you're racing around the globe. It seems like I spend half of my life jet lagged. And we go around the globe and going through the different things. When we're there, we're down to the last steps now. And, when we went through the big qualification exams last week, this was the prime crew, and all eyes are on us, and making sure we're ready. And we are. The crew has really come together really well, and just had a great day in the Soyuz sim last Friday, and just nailed it. And that's such a great feeling.
I know one of your sons graduated in pilot training.
Right.
I believe just a few months ago, and what are his thoughts on his dad going up on a Soyuz just a few weeks from now?
He thinks Dad's a little nuts, but my kids have grown up, knowing me and the space program and living this dream in the early years before I was selected, and then going along with us now. I'm blessed to have 4 children. 2 of them are married, and a granddaughter now that's about 10 weeks old. And leaving that little girl behind was probably the hardest part of the whole thing.
Внимание. Все, спасибо. Дублирующий экипаж. Okay. Right. Okay.
Just stand there. This is one of the most solemn of the traditions for the Russian space program and preparing to go fly is a visit to Red Square. What we have behind me is the wall of the Kremlin. These are some of the heroes of the Soviet Union and heroes of Russia with great distinction who are actually, their ashes are entombed here in the wall of the Kremlin. And we come by to put flowers on the graves of Yuri Gagarin and Sergei Korolev, to honor them as the pioneers of the space program, and we really walk in their shadows and stand on their shoulders as we're reaching up to space. So it's a really a neat thing to participate in as an American. We recognize the achievements of our Russian comrades and the other pioneers and travelers who came before us. It's really an honor to be part of this today.
Внимание. Спасибо.
And everybody can get in the picture if you like as well.
Yes.
Mike, what are your feelings today on visiting this historic area here at Red Square?
Oh, we're inside the Kremlin walls here, and it's a place of such historical significance. Really, the Red Square area, downtown Moscow, is one of the most famous places, the most recognizable places on the planet. And for me, it's such a great thing to be here, to have the ceremonies out on the Red Square itself, and then inside the Kremlin walls with some just really historic artifacts that are significant in Russian history that they have on display here. And so every crew comes here just to visit, to touch these things of national historical significance, and to take our picture here. It's just part of the pomp and circumstance. It's part of the ceremony. It's part of the progression that we have as we move closer and closer to launch to take part in these traditions.
That's a good angle.
Firing chain is armed. Suppression water system is armed.
The water system, main engines will light in a moment.
Power for main engine start.
Main engine starting.
6.
Come up to full speed. Computers check it.
0 and liftoff on the final launch of Endeavour. Expanding our knowledge, expanding our lives in space. Endeavour, whole program. Roger, roll.
Go Endeavour. Roger, roll.
This is Mission Control Houston, back with a live view inside the Space Shuttle Flight Control Room. That again was a look at NASA TV video file, which today featured the crew news conference for the members of the Expedition 28 crew who are going to be launching on June 7th to join their crewmates already on orbit. That was Mike Fossum, Sergei Volkov, and Satoshi Furukawa. At the moment, the teams here in the Space Shuttle Flight Control Room are in the middle of handing over, just about to wrap it up. Flight Director Quatsi Alabarujo is going to be replacing Paul Dye as the Flight Director for the room. Dye is the outgoing Orbit 2 Flight Director, with Alabarujo coming in for the planning shift. And Capcom Shannon Lucid will be taking Mike Massimino's place at the microphone for the crew's sleep period. They did officially enter their sleep period and now are about 7 hours and 11 minutes away from the beginning of their second day in orbit. While the crew, or while we were in that video file, the crew did finish downlinking some of their flight day highlights, and you'll be seeing those in our regular showing of the flight day highlights that's coming up starting at 4 p.m., and which will be replayed at the top of every hour while the crew is asleep. That, again, is coming up at 4 p.m. Central Time.
This is Mission Control Houston. The Orbit 3 team of flight controllers is now on duty here in the Space Shuttle Flight Control Room as Endeavour continues its approach to the International Space Station on a mission to expand our horizons into dark matter and antimatter with the Alpha Magnetic Spectrometer. The team here is the planning shift, or Orbit 3 team, just completed a handover from the Orbit 2 offgoing team. Kwatsi Ali Barujo is the flight director in charge right now. Shannon Lucid, veteran astronaut, will be the spacecraft communicator. Not a lot of communications expected with the crew between now and wake up, as the crew was given a good night by Mission Control just a few minutes ago, and we shouldn't be having any more contact with them until it's time for wake up. We are coming up at the top of the hour on our Flight Day 1 highlights package. Scheduled to begin airing at 4 p.m. Central Time, 5 Eastern. We are in the process still of pulling in some video that was downlinked while we were running that video from Russia relative to the next space station crew members headed for the International Space Station. And so it may take us a little bit longer to get that all edited together and ready to start. We may start a couple of minutes late, but the next event on NASA television will be today's Flight Day highlights package. This is Mission Control Houston. After checking the status of our flight day highlights package, we've determined it's going to be 5 o'clock before we're able to get all the editing done. So today's Flight Day 1 highlights will air first at 5 p.m. Central Time, 6 p.m. Eastern, and then, of course, we'll be running that highlights package at the top of every hour during the crew's sleep shift. In the meantime, let's take a look at a video package that gives an overview of the objectives of this STS-134 mission, the 25th mission of Endeavour, a mission to the International Space Station.
Booster ignition and liftoff of the maiden voyage of Endeavour on a satellite rescue mission.
For the past 2 decades, Space Shuttle Endeavour, the youngest vehicle in NASA's shuttle fleet, has symbolically carried the torch for Challenger, the orbiter it replaced. NASA is preparing for the final flight of Endeavour, a trip to the International Space Station during a time frame in which astronauts and cosmonauts are celebrating the 50th anniversaries of the first human spaceflight by Yuri Gagarin and the first American spaceflight by Alan Shepard, as well as the 30th anniversary of the first space shuttle flight, STS-1 Columbia. This historic 25th flight of Endeavour will include delivery of the Alpha Magnetic Spectrometer, a unique instrument that is hoped to unveil clues to the origin of our universe as it searches for antimatter, dark matter, and exotic cosmic particles from the space station. When Endeavour launches on NASA's 36th mission to the ISS, the STS-134 crew of 6 astronauts will begin a mission to stock the station with spare parts and a world-class stellar research instrument just months before the shuttle program comes to an end. Endeavour will deliver the Alpha Magnetic Spectrometer 2 and the Express Logistics Carrier 3 to the station. This will also be the first shuttle flight to conduct a re-rendezvous, but not dock to the space station, to test the performance of new navigation sensors designed for the Orion spacecraft. During 4 scheduled spacewalks, Endeavour's crew will conduct the last spacewalks by shuttle crew members to prepare the ISS for its next decade of service.
I've flown on Endeavour before, so I'm excited to fly on it again. And my brother's flown on Endeavour.
Navy Captain Mark Kelly is the commander of Endeavour's crew of 6 astronauts. He flew on Endeavour as the pilot of his first space flight, STS-108, in 2001. In January 2011, Kelly's wife, Congresswoman Gabrielle Giffords, was critically wounded during a community outreach event in Tucson, Arizona. Kelly took a brief leave from the agency, but returned to mission training a few weeks later. The pilot of Endeavour is retired Air Force Colonel Greg H. Johnson, making his second space flight. He will be at the controls as Endeavour undocks from the station. He flew on Endeavour as the pilot of STS-123 in 2008. Air Force Colonel Mike Fink is Mission Specialist 1. A veteran of 2 long-duration missions on the International Space Station, he commanded the station complex on Expedition 18. During this mission, his first aboard the shuttle, he will conduct 3 spacewalks. Mission Specialist 2 is Italian Air Force Colonel Roberto Vittori, twice flown aboard a Russian Soyuz as an ISS visitor and part of the crew that delivered fresh Soyuz spacecraft to the outpost. As the last non-American astronaut scheduled to fly on the shuttle, Vittori will meet up with Paolo Nespoli on the ISS for 2 Italian astronauts on orbit at the same time. Dr. Drew Feustel, Mission Specialist 3, is making his first voyage to the ISS after performing 3 spacewalks during STS-125, the final Hubble Space Telescope servicing mission. On this flight, he will serve as lead spacewalker for 3 additional EVAs. Mission Specialist 4 is Dr. Greg Shamatoff. He served as an ISS flight engineer for 6 months during Expeditions 17 and 18, returning to Earth on Endeavour. He will perform 2 spacewalks.
We've got a whole list of mission objectives, probably 30 things on the list. But the big objectives is to get the Alpha Magnetic Spectrometer installed on the outside of the space station.
The Alpha Magnetic Spectrometer 1, a simplified cosmic ray detector, flew on STS-91 in June 1998. The AMS-2 is a first-of-its-kind instrument designed to study the fundamental nature of the universe and will allow us for the first time to search for antimatter and dark matter theorized to exist. Nobel physicist Dr. Samuel Ting leads the team of over 500 scientists from 16 countries.
I started studying physics. Soon after I achieved my degree as a test pilot, I went back and complete my degree. And ironically, my teacher was Professor Battiston, that is the deputy chief of the AMS experiment. It may appear as a very strange coincidence that today I will be the one to take this unique piece of hardware, take it from the bay of the shuttle, and give it to install on the station.
On Flight Day 4, Vittori and Feustel, operating the shuttle arm, will grapple the AMS-2 and hand it off to the Gregs, Johnson and Shamatoff, operating the station arm for robotic installation onto the station's S3 truss. The second of 2 components that Endeavour's crew will attach to the ISS is the ELC-3 pallet, the Express Logistics Carrier 3. ELC-3, similar to ELCs 1 and 2 delivered on STS-129, includes a full ATA, ammonia tank assembly, 2 SASs, S-band antenna support assemblies, and a spare arm for Dexter, the special-purpose dexterous manipulator. On Flight Day 3, Vittori and Fink will unberth the ELC-3 with the shuttle arm and hand it off to station arm operators Shamatoff and Johnson for installation on the station's P3 truss. STS-134 will be the first shuttle flight to re-rendezvous with the ISS and to fly a rendezvous trajectory to mimic Orion's trajectory. The purpose of STORM, Sensor Test for Orion RELNAV Risk Mitigation, is to evaluate the performance of Orion relative navigation sensors for future spacecraft. While Kelly is flying Endeavour, Feustel will monitor STORM sensors from a laptop on the flight deck during rendezvous, undocking, and the re-rendezvous after the traditional ISS fly-around. Endeavour will pull away from station and execute several maneuvers before approaching on a different trajectory to allow the STORM vision navigation sensors to gather data. Although Endeavour will not actually redock with ISS, it will fly to a close approach of 1,044 feet below and 300 feet behind the station before executing a 3rd separation burn and departing station for the final time.
Then when we come up back in front of the space station again, we're then going to do these series of burns where we're going to fall behind the space station, a couple 100,000 feet. And then we're going to come back in doing a profile that's actually quite similar to what Apollo used for a rendezvous.
During STS-134, Feustel, Fink, and Shamatoff will take turns stepping outside the hatch for 4 scheduled spacewalks. EVA-1 on Flight Day 5 focuses on MISSES, Materials International Space Station Experiments. Feustel and Shamatov will return the Missy 7A and 7B pallets from the ELC-2 and transfer Missy 8 to the same location.
The idea is to expose these things to the harsh environment of space for a long period and see what happens.
For EVA-2 on Flight Day 7, Fink and Feustel will refill one of the station's port radiators with ammonia. They will also clean and lubricate the station's port Sarge, the solar array rotary joint. Prior to EVA-3, Feustel and Fink will test a new protocol combining the airlock campout pre-breathe, the exercise pre-breathe, and the spacesuit itself.
We were introduced to a pre-breathe option by Mike Gernhardt, an astronaut in the Corps, and it's called the In-Suit Light Exercise Pre-Breathe Protocol. We call it ISLE, I-S-L-E.
For EVA-3 on Flight Day 9, Feustel and Fink will install a power and data grapple fixture for the station arm on the Zarya module. They will also run 2 Y cables for redundant power supply to the Russian portion of the station. During EVA-4, Shamatov and Fink will transfer and install the OBSS, the shuttle arm's extension boom, to the station's S1 truss for potential future use aboard the ISS.
We have come very far in the last 50 years from not being able to fly in space to landing on the moon and building this incredible facility in orbit and routinely flying people up and down into low Earth orbit.
It is amazing how much we've accomplished in 50 years, and it took so many people to make all that possible. It's an unbelievable honor to kind of be the representative of that generation of dreamers for me.
We have a huge honor and responsibility to make this the best mission that we can, to honor all of the engineers all the way from the pre-STS-1 in the very beginning in the 1970s when we started to design the space shuttle. All the effort, the blood, the sweat, the tears that have gone into making the space shuttle program as wonderful as it has, to fly on the penultimate mission and to do it well and to do it with the honor of those that came before us.
This is Mission Control Houston. Back with live activities inside the flight control room, where Quetzala Barujo, the flight director, watches over the systems aboard the Space Shuttle Endeavour as it begins its mission to the International Space Station. Shuttle currently in an orbit that's 204 by 201 statute miles high. We're about 1,726 miles behind the International Space Station, catching up by approximately 103 statute miles every trip around the world. Of course, both vehicles traveling approximately 17,500 miles an hour. Shuttle and station have both just passed over the eastern portion of South America and are heading out over the South Atlantic, just to the south of the southern tip of Africa. In addition to the folks here in the Space Shuttle Control Room, the International Space Station Flight Control Team continues its duties, watching over the orbiting outpost. Dina Cantella is the flight director on duty with Dan Tani, the spacecraft communicator, talking to the Expedition 27 crew aboard the International Space Station. The Expedition 27 crew includes Commander Dmitry Kondratyev, flight engineers Paolo Nespoli and Katie Coleman, along with Andrei Borisenko, Alexander Samakotyayev, and Ron Garan. They are getting ready for the departure of Kondratyev, Nespoli, and Coleman, who are getting ready to depart the International Space Station and head for home, awaiting the arrival of the next three crew members. Of course, we saw their video of their launch preparations from the Star City Training Center just a little bit earlier today. Mike Fossum, Sergei Volkov, and Satoshi Furukawa getting ready to head for their 6-month stay aboard the International Space Station. And of course, aboard STS-134, headed for the International Space Station, are Commander Mark Kelly, pilot Greg Johnson, and flight engineer Roberto Vittori of the European Space Agency, along with Mike Fink, Drew Feustel, and Greg Shamatov. Everything looking very good on board the Space Shuttle Endeavour as they get ready for a 2-week mission to deliver the Alpha Magnetic Spectrometer, along with a large spare parts platform, and also for some important servicing work on the solar alpha rotary joints that allow the solar arrays to rotate and track the sun, providing electricity for the space station. And that's one of the key reasons that the Alpha Magnetic Spectrometer is being delivered to the station, because it will provide the power platform necessary to drive all of the sensitive instruments that will be looking at the different particles in space that could help give us an increased understanding about matter, antimatter, and dark matter. We have another video package that takes a look at the goals of the Alpha Magnetic Spectrometer. There happens to be a team just down the hallway here in Mission Control that is watching over its systems. So far it is being activated, and all parameters are looking very good. But let's go to that video package and look at what the goals of that experiment that will be mounted on the space station's truss are.
When it comes to understanding the universe, we are only beginning. Humankind continually searches for patterns, trying to figure out, what is the universe made of? How does it work? How does our planet, our solar system, our galaxy fit in with the other pieces? And what don't we know yet? Helping us discover more pieces of the puzzle will be a new instrument on board the International Space Station called the Alpha Magnetic Spectrometer, or AMS. AMS is not a telescope. Rather than looking at space, It will sift through space, studying the high-energy particles of cosmic rays. From the unique vantage point of Earth orbit, the AMS experiment has the potential to answer questions about the origins of our universe. It began with a bang. The Big Bang Theory postulates that the universe was created in a great explosion. But there are some puzzle pieces missing regarding the Big Bang. During this explosion, matter and antimatter should have been created in equal amounts. But we have a hard time finding the antimatter in the universe. Where is it, and what exactly is the universe made of? We don't know for certain yet. Here's another missing piece. Astronomers have determined that galaxies have 10 times the mass than what we see of stars, gas, and dust. What accounts for this missing mass in galaxies? The answer may be dark matter, a mysterious material that exerts gravitational pull but does not absorb or emit light. But we have yet to find dark matter. The study of high-energy particles might help in the search for dark matter and antimatter in the universe. Nobel Prize-winning scientist Professor Samuel Ting, well known for groundbreaking particle physics work on Earth, has collaborated with an international team to create the Alpha Magnetic Spectrometer, a high-energy particle detector that takes particle science into space. He and his colleagues hope the AMS will help answer some of these nagging questions about the universe.
If the universe has come from a Big Bang, and so you have matter, you must have antimatter. Now the universe is close to 15 billion years old. The question is, where is the other half? Where is the universe made out of antimatter?
An Alpha Magnetic Spectrometer flew on board the Space Shuttle in the 1990s, but that mission was only for a few days, merely proving the concept of flying this type of hardware in space. While valuable science was gleaned from that mission, the AMS on the station will stay for years, with instrumentation that is far more sensitive and far more precise than what was flown before. With over 300,000 data channels for detection and over 600 onboard microprocessors to analyze the data. The AMS is sponsored by the Department of Energy, and scientists from 16 countries lent their expertise to create it. Parts from around the world were sent to CERN, the European Organization for Nuclear Research, in Geneva, Switzerland. NASA had the job to figure out how to get the 15,000-pound experiment into Earth orbit and have it operate in the hostile environment of space. The AMS was finally sent to the Kennedy Space Center, where it was ready to fly on board a space shuttle, the final large component of the space station to be sent on one of the last shuttle flights. Part of the shuttle crew is European Space Agency astronaut Roberto Vittori, who will operate the shuttle arm to grasp the AMS from the shuttle payload bay.
That means that I will have the responsibility with the shuttle robotic arm to take it from the payload bay and offer to the station. But behind that specific operational task, there is a very long history. I started about 20-25 years ago to study physics, to think about space, to think about the universe. And the specific of the search of the antimatter was one of my main and deep interests. It may appear as a very strange coincidence that today I will be the one to take this unique piece of hardware, take it from the bay of the shuttle and give it to install on the station.
For the AMS, there are many benefits to having a fully functional space station as your home.
So AMS weighs 15,300 pounds. Most of that is science experiments. We do not have to carry our own power. We do not have to carry our own data systems to transmit that data back to Earth because all of those systems are provided to us by the space station. It's a perfect example of how you can utilize the capabilities of the International Space Station to fly groundbreaking science experiments.
So how exactly does the AMS work? One thing it is not is a telescope. Telescopes measure photons, packages of light, both visible and invisible to the naked eye. This type of astronomy has given us most of our knowledge of the universe thus far. But the cosmos speaks to us in languages other than light. For the AMS, this will be the first time scientists study charged particles. Exploding stars and other celestial phenomena are thought to produce cosmic rays which travel across the universe and can wash up on the shores of our planet. The rays are composed of charged particles, but many of these are absorbed in our atmosphere, making it impossible to study them on Earth. But outside our atmosphere, on the space station, the AMS will be able to sift through these particles, helping us search for antimatter, dark matter, and the stuff of which the universe is made. A particle will pass into the AMS. Layer upon layer of detectors tells us the mass, energy, and velocity of the particle. Other detectors tell us which direction or path the particle took as it passed through the AMS. At the heart of the unit is a magnet that will make the particle curve one way or another, telling us whether it is matter or antimatter. And just how quickly does all this particle detection happen?
Faster than I can snap my fingers. Nanoseconds. In nanoseconds. AMS gathers data at a ridiculously large rate. We will see about 25,000 hits per second of cosmic rays coming into the aperture of AMS.
If, while sifting through the cosmic sands, the AMS strikes gold, 2 star trackers on board the experiment will help scientists determine from where in the universe the particle came. The AMS can send its volumes of data utilizing the station's communication link with Earth. Teams of scientists all over the world will study that data, looking for particles of dark matter, antimatter, and the unknown. So what will we find? Nobody knows. In the science of particle physics, anything is possible, and often the quest for one answer instead reveals another discovery not dreamed of. If the cosmos is the ultimate particle accelerator, it should provide plenty for the AMS to analyze. The experiment will stay on board the space station for as long as the station is in orbit, silently sifting through the particles, helping scientists find those missing pieces to the puzzle of our universe, and perhaps finding something new for us to explore along the way.
This is Mission Control Houston, back with live coverage from the Control Center here, the Christopher C. Kraft Jr. Mission Control Center. Reminder that coming up next on NASA TV will be the Flight Day 1 Highlights package. First airing of that package coming up at 5 p.m. Central Time, 6 Eastern, and then we'll be replaying the package at the top of the hour throughout the crew's sleep shift. This is Mission Control Houston as the Orbit 3 or planning shift begins its preparations to get the crew ready to go about its day on the first full day on orbit after a successful launch this morning. Let's take a look at the package that we have that gives some of the background for Commander Mark Kelly, Pilot Greg Johnson, and Mission Specialist Roberto Vittori, Mike Fink, Drew Feustel, and Greg Shamatov, who will be accomplishing the objectives of the STS-134 mission to the International Space Station. Let's look at that package now.
Ready? On 2, 1, 2.
Each member of the crew for Space Shuttle Endeavour's final flight has been to space before. In fact, STS-134 is the 4th trip to the International Space Station for U.S. Navy Captain Mark Kelly, tying the record for the most visits. Kelly was born in Orange, New Jersey, and grew up in West Orange. As a young boy watching the Apollo moon landings, he thought about becoming an astronaut, but as he got older, it seemed out of the question. After high school, Kelly won an appointment to the U.S. Merchant Marine Academy with a plan for a career at sea. Then he made a trip on a grain carrier.
Going from Seattle to a place called Savaga, Egypt. It's in the southern part of Egypt on the Red Sea. And getting across the Pacific, that ship went 12 knots. And it took us over a month to get across the Pacific Ocean and get us to Singapore. And I thought, boy, this is way too slow. So that's when I started thinking about flying airplanes in the Navy.
When he finished his bachelor's degrees in marine engineering and marine transportation at the Academy, Kelly took his commission and went to the Navy Flight School. He made 2 deployments during Operation Desert Storm and flew 39 combat missions. Earned a Master of Science in Aeronautical Engineering at the Navy Postgraduate School, and then went to the Navy Test Pilot School, where the astronaut bug bit him again.
You know, being a test pilot's fun. You get to test new things and sometimes fly new airplanes. And the space shuttle, you know, after STS-134 only has 134 flights. It's still more or less in a test program, even though we've been flying it for nearly 30 years now. So it's like the ultimate test pilot job.
Kelly was an instructor at Test Pilot School when he was picked for the Astronaut Corps in 1996. Kelly was the pilot on shuttle mission STS-108 in 2001 and the second return-to-flight test mission in 2006. And he commanded the 2008 flight that delivered the Kibo laboratory module. Air Force Colonel Mike Fink has been to the station twice before, for a year on 2 long-duration missions, and he'll set a new record for time spent in space by an American at the end of this flight. Fink was born in Pittsburgh, Pennsylvania, and grew up in the suburb of Emsworth.
And I was the oldest of 9 kids. We didn't have a lot of money, but we're still able to spend time in planetariums and the museums and the science centers that are all over the city. Had a benefit and blessing to be able to go to a private high school. I had to work on the weekends to make it happen, but the school made it work too. And I had a great, excellent education in high school, studying science and math and all the things that really excited me.
Fink won an Air Force ROTC scholarship to MIT, where he earned bachelor's degrees in aeronautics and astronautics and Earth, atmospheric, and planetary sciences. That summer, he attended an exchange program with the Moscow Aviation Institute before heading to Stanford for a master's in aeronautics and astronautics. Then he started an abbreviated career as a fighter pilot.
And it turns out after 6 or 7 months, the Air Force and I both agreed that I wasn't going to be the God's gift to aviation that I thought I was going to be, and I wasn't destined to become a fighter pilot, so I washed out of pilot training.
Fink found his niche as an engineer and then a flight test engineer, attending the Air Force Test Pilot School and serving at posts in Southern California and later in Japan. But he never gave up his childhood dream.
When I was 3 years old, I remember watching people walk on the moon. And I knew right then and there that's something I wanted to do.
Fink was selected as an astronaut in 1996. He spent 6 months as flight engineer on the International Space Station's Expedition 9 in 2004 and performed 4 spacewalks. Then another 6 months as commander of Expedition 18 and performed 2 more EVAs. One of his crewmates from that flight is with him again on this one. Dr. Greg Shamatov was born in Montreal, Canada, and had a father he describes as a space fanatic. Shamatov remembers watching Star Trek as a little boy and being intrigued.
But then we went on a family vacation to Florida, and it was the time of Apollo 11, so we got to see the launch of Apollo 11 on a family vacation there. I was 6, and that was it. I told my dad at that point I wanted to do that and never changed my mind.
The family moved to the United States and settled in San Jose, California when Shamatov was 11. He graduated from high school there and went to Cal Poly in San Luis Obispo to study physics. The launch of the first space shuttle mission during his freshman year changed his focus.
And I just remember so vividly being in the dormitory, you know, people gathered to watch the first flight. And for me, you know, I'd wanted to do this all my life, but there wasn't, wasn't any urgency or sense of direction, you know, of how to do it. And as soon as that happened, I said, I got to call NASA and ask them what I have to do.
When he got interested in robots, he changed his major and earned a Bachelor of Science in Electrical Engineering at Cal Poly, then a Master's in Aeronautical Engineering at Caltech. On a fellowship at Draper Laboratory in Cambridge, Massachusetts, Shamatov worked on spacecraft guidance controls for several NASA projects while earning his doctorate in aeronautics and astronautics at MIT. Then he taught aeronautical engineering at the University of Sydney before he came to work at the Johnson Space Center in 1995, developing software applications. He was picked for the astronaut corps in 1998 and spent 183 days in space as part of the space station's Expedition 17 and 18 crews. Italian Air Force Colonel Roberto Vittori of the European Space Agency has made 2 previous trips to the International Space Station, but he spent less than 3 weeks in space. Vittori was born in Viterbo and grew up in nearby Bomarzo in central Italy.
Very small, in the middle of a beautiful forest in countryside, and I grew up playing soccer outside my school. I was very good in defense, and that was and then I loved playing in the woods with my friends.
He left Bomarzo for college to study physics, but his boyhood interest in flying reasserted itself. Vittori earned a bachelor's degree in aeronautical science at the Italian Air Force Academy and completed his basic pilot training with the U.S. Air Force at Reese Air Force Base in Texas, and then flew operationally in the Italian Air Force. Next stop was the U.S. Navy Test Pilot School and a post-graduation trip with his classmates to visit NASA.
All my colleagues, American colleagues, were thinking about becoming an astronaut, and I was thinking, bad luck that I am not US. Obviously, in Italy, it's not that easy to have opportunities for astronauts.
2 years later, while Vittori was working as a test pilot in Italy, he put in an application when the Italian Space Agency was looking for astronauts. He was selected and became a European Space Agency astronaut, and trained as a member of the 1998 class of astronauts at NASA's Johnson Space Center. Vittori flew to the International Space Station on a Soyuz taxi flight in 2002, and then on a 10-day science flight in 2005 during the Expedition 10 to 11 crew exchange. He later served as an Italian Air Force liaison officer and completed master's degrees in aeronautical sciences at the University of Naples and in physics at the University of Perugia. This flight is the second station trip for retired Air Force Colonel Greg Johnson. Johnson was a military brat, born in the United Kingdom and raised all over the United States. He was inspired to become an astronaut during a family visit to his grandparents in Traverse City, Michigan, when they all watched the Apollo 11 moon landing.
I was 7, my brother was 9, my sister was 11, and we were amazed, and I said, wow, I'd love to be an astronaut. So that was kind of the bit that was set way back when I was 7.
Johnson graduated from high school in Fairborn, Ohio, and went to the Air Force Academy to become a pilot and an engineer. After graduating with a Bachelor of Science in Aeronautical Engineering and earning a Master's in Flight Structures Engineering at Columbia, Johnson was assigned to Reese Air Force Base as a pilot and then a pilot instructor. He flew combat missions in Operations Desert Storm and Southern Watch before attending the Air Force Test Pilot School, which rejuvenated the engineer in him and made him think about his childhood dream of becoming an astronaut.
I'm flying really cool stuff, and they like to hire test pilots because each shuttle mission really is a test flight. And so went ahead and threw my name in the hat.
Johnson was selected by NASA in 1998, earned an MBA from the University of Texas at Austin in 2005, and piloted the 2008 shuttle flight that delivered the first components of Japan's Kibo laboratory complex. Dr. Drew Feustel's first spaceflight got him nowhere near the International Space Station, but he got up close to something that none of his crewmates has ever seen before. Feustel was born and raised in Lake Orion, Michigan, north of Detroit.
You have fond memories of summer and winter. You know, I think winters were quite enjoyable. We used to do a lot of snowmobiling and snow skiing, and in the summers we spent our time water skiing. And being a suburb of Detroit, Motor City, I became interested in automobiles at an early age.
Feustel raced motorcycles and go-karts as a boy, and he had cars in mind after high school when he went to Oakland Community College,
specializing in geology with a minor in industrial design. So you could say I was pursuing two careers, one as a scientist, one as an automotive designer,
while working as an automotive restoration mechanic. After he finished his associate's degree, he went to Purdue for a bachelor's in solid earth sciences and a master's in geophysics, and was the team kart driver for his fraternity. And then he earned a PhD in geological sciences at Queen's University in Kingston, Ontario. He worked as a geophysicist in Canada and then for ExxonMobil Exploration in Houston before he was picked as an astronaut in 2000. Feustel completed 3 spacewalks during the final servicing mission to the Hubble Space Telescope in 2009.
I think for humans it's always been about what's out there, are we alone, could we be the only ones in this infinite universe? And I think the only way we're going to find out is if we keep pushing the boundary and trying to get out there, and this is just the beginning.
This is Mission Control Houston. That concludes our package on the backgrounds of the STS-134 crew members. Katie Coleman, meanwhile, on board the International Space Station, recently sent down some recorded views of the Florida Peninsula as the International Space Station orbited overhead at an altitude of approximately 220 statute miles. We're taking a look at her replay of that recording from on orbit that's coming down as we speak. Of course, launch occurred today at 7:56 a.m. Central Time from the Kennedy Space Center in Florida.
I never saw it in those little teeny portholes. Ron, come unscrew this thing. Hey, Ron.
Yeah?
Come undo this. Second, right here. I'm holding the camcorder steady.
As Endeavour began its 25th and final flight into orbit.
Good audio. And then you can park it. Park it there. So back, see, you see North Carolina sticking out there? And it's back further than that, so it's going to be straight out that direction. So turn this.
How long is the countdown? Was it 57 what?
56. Here, here, I can move that. Just give you more room. Or do you want to be on this side? I'll move it.
As we continue to watch this recorded downlink of the east coast of the United States as the International Space Station flew overhead a little bit earlier on this orbit. Mentioned that the Space Shuttle Endeavour, which launched this morning, is carrying a mix of new research to be performed on the International Space Station after the shuttle mission. Some 150 experiments are continuing aboard the space station as the transition from assembly work to expanded research on the outpost continues and to progress. Research includes basic categories of biological and biotechnology research, human physiology research, physical and material science research, technology development, and earth and space science, as well as educational activities. Among the new experiments flying will be several experiments flown by NASA in cooperation with the Italian Space Agency, including one that looks at how some kinds of memory-shaped foam, the same kind of thing used in beds on Earth, might be used as a new kind of actuator. An actuator is a servo mechanism that supplies and transmits a measured amount of energy for different mechanical purposes. The U.S.-Italian experiments also are going to be looking at cellular biology, radiation, plant growth, and aging, as well as at how diet may affect night vision and how an electronic device might be able to be used for air quality monitoring in spacecraft. One particular NASA experiment known as biology will use, as among other samples, C. elegans worms that are descendants of worms that survived the STS-107 Columbia Space Shuttle accident. The rapid turnaround engineering proof of concept test is going to use the newly arrived light microscopy microscope on board the space station to look at three-dimensional samples of live organisms, tissue samples, and fluorescent beads, including those C. elegans worms. There's also a NASA educational payload that's going to be delivering toy Lego kits that can be assembled to form satellites, space shuttles, and a scale model of the space station itself on board the station. That'll be used to demonstrate scientific concepts. There's also a Japan Aerospace Exploration Agency experiment called Tri-0G that will help future astronauts show children the difference between microgravity and Earth gravity. And so the Space Shuttle Endeavour, in addition to serving as a delivery truck to take these experiments, also will have several different experiments being performed on the Space Shuttle itself on its way to the International Space Station and after departure. Again, this is some video that was shot from on board the International Space Station as flight engineer Katie Coleman trained the cameras on the Earth below. The particular orbit this was taken on was a southeasterly track that went over the Florida coastline. Currently, the shuttle and the station are tracking on a northeasterly path, with the shuttle just now passing over the equator as they head off the eastern coast of Asia and Japan. And a reminder that our next event on NASA television coming up at the top of the hour will be today's first airing of the Flight Day highlights for the launch activities today. The Flight Day highlights package will air for the first time at 5 p.m. Central, 6 p.m. Eastern, and then we'll replay that at the top of the hour for each hour during the crew sleep shift. Today's package is about 34 minutes long.
No. Can you give me number 4? Number 4 what?
Back now with some more of that recorded video from Katie Coleman aboard the International Space Station, where she is staying with...
I mean, if we're going to see it, we should see it now. Can you give me 4?
Yeah, window 4? Sure.
Give me 4, I don't see it.
What's that?
Can you punch 4?
Oh, sure. Oh, we didn't know you had a code card.
You said window 4. Paolo, ci siete sempre? Paolo, ci siete sempre?
There you go. Now.
Paolo, ci siete sempre?
I'm just too far behind.
Hi, I'm Mark Kelly, commander of STS-134, and you're watching NASA TV.
Endeavour will also bring up to the station the Express Logistics Carrier 3, an external platform for the space station that holds large equipment that will carry spare parts and equipment to sustain the space station's operation in space once the last space shuttle flight has occurred this summer. There are 4 planned EVAs, or spacewalks, outside the International Space Station during the STS-134 mission to do maintenance and install new components. And here is Commander Mark Kelly, our 134 mission commander, making his 4th flight on the space shuttle. He's logged a total of 38 days in space. His latest flight was in 2008 on STS-124. Going over to our pilot now, Greg Johnson. He's making his 2nd space flight, previously also piloted on STS-123 in 2008. He's logged over 4,000 hours in 40 different type of aircraft. This is Mike Fink, Mission Specialist number 1. This is his 3rd space flight, but his 1st space shuttle flight. He was launched previously from Russia on Soyuz spacecraft, and he's logged 365 days in space with over 26 hours on 6 spacewalks. Mission Specialist Greg Shamatoff. This is his 2nd space flight, but he's already logged 183 days in space aboard the space station. He's Canadian-born from Montreal. And there's Drew Feustel, Mission Specialist number 3, making his 2nd trip into space. He served as an astronaut for more than a decade, working on both the Space Shuttle and the Space Station branches in Houston. He flew on the 5th and final HST servicing mission. And Roberto Vittori. He's mission specialist number 2. He was selected as an astronaut by the European Space Agency. He's from Viterbo, Italy. And he has flown to the International Space Station twice. And here come our astronauts, leaving the suit-up room bound for the elevator that will take them down to the astronaut van, the Astrovan. This is the same elevator that all astronauts since Apollo have used to leave the crew quarters and go out to the launch pad. It's about a 20-minute ride from the astronaut quarters out to the launch pad, covering about 10 miles, and they allow another 10 minutes or so for the crew to get off the Astrovan and look around a little bit and head up the fixed service structure and then begin boarding the space shuttle. So that allows for about a half an hour for the entire process from the time they leave the astronaut quarters until they start boarding. And there they go.
OVCC, they're at the pad.
And the astronaut van now on the pad surface. Crew taking a moment to look at Space Shuttle Endeavour, something that most crews like to do before they head up to board the spaceship.
And OTC, OVCC.
OVCC, OTC, go.
My crew has arrived at the orbiter. Crew ingress and work at this time.
See that.
Drew Feustel is up next. He's mission specialist number 3, making his second trip into space. He's served more than a decade as a NASA astronaut, working on both the Space Shuttle and the Space Station branches. Greg Johnson, he's about to board.
OTC, OVCC.
VCC, OTC.
MS3 on board at this time.
0940.
This is a live shot from the mid-deck area. This is Mission Specialist number 4, Greg Shamatov. STS-134 is his second space flight, but he's already logged 183 days in space aboard the International Space Station.
OTC CDR, com check. CDR, this is OTC. I have you loud and clear. Good morning, Mark. Hey, good morning. How are you? Very good. It's CMQC 65.
Roberto Fattori and Mike Fink waiting to enter the white room.
And CGSS OTC.
OTC CGLS.
CLS OTC.
Yes, sir. I can give you steps 592 through 598. We've completed implementation of step 92.
Copy that. Thank you.
Greg Shamatov now on board. He's going to be sitting in the mid-deck center seat, joining Drew Feustel on the mid-deck. This is astronaut Mike Fink. He's Mission Specialist number 1. This is his third space flight, but his first space shuttle flight. He's logged over 365 days in space, with over 26 hours on 6 spacewalks on the International Space Station on expeditions 9 and 18.
OTC, TLT, com check. TLT, OTC, I have you loud and clear. Good morning, box. Good morning, Mark. Your checklist. Copy that. And CMQC 690, 692 are complete as well.
This is Roberto Fattori, our Mission Specialist number 2. He was selected as an astronaut by the European Space Agency and is from Viterbo, Italy. And he has flown to the International Space Station on 2 past occasions.
OTC, MS4, com check. MS4, OTC, I have you loud and clear. Welcome aboard, Greg. Thanks, Mark. Also have you loud and clear.
OTC CWS.
Double S, go.
I can verify step 685.
Thank you.
And Roberto Vittori now climbing on board Endeavour.
And OTC, OVCC.
Mission Specialist number 2.
MS2 on board at this time, and that is all crew members on board.
So all of the crew members are now on board.
Please pass that to fire rescue leader.
Copy that.
And NTD, your polls go. Is that affirmative?
That is affirmative. We are all go.
Okay, copy that. KC Chief Processing Engineer, verify no constraints to launch.
No constraints.
Thank you, Steve. KC Safety and Mission Assurance.
KC Safety and Mission Assurances, go.
Thank you, Dave. Payload Launch Manager.
Mike, Space Station Processing Teams, go.
Thank you, Bill. Range Weather.
Weather has no constraints to launch.
Thank you, Kathy. And Ops Manager.
Mike, things look real good today. Thanks to your team for getting us back here. You're a good launch Endeavour.
Good. Thank you, sir. Endeavour Launch Director, Air to Ground 1. Okay, Mark, looks like a great day to launch Endeavour for the final time. So on behalf of the thousands of proud Americans who have been part of her journey, good luck, Godspeed, and we'll see you back here June 1st.
Thank you, sir. On this final flight of Space Shuttle Endeavour, we want to thank all the tens of thousands of dedicated employees that have put their hands on this incredible ship and dedicated their lives to the Space Shuttle program. As Americans, we endeavor to build a better life than the generation before, and we endeavor to be a united nation. In these efforts, we are often tested. This mission represents the power of teamwork, commitment, and exploration. It is in the DNA of our great country to reach for the stars and explore. We must not stop. To all of the millions watching today, including our spouses, children, family, and friends, we thank you for your support. Endeavour OTC, it's your final voyage. This is both a sad and proud moment for your launch team and for America, but your legacy will live on. Mission success with AMS, a truly international effort. Godspeed, and see you back in a couple of weeks. Endeavour copies. Thanks for the words. Appreciate it. OTC, PLT, caution and warning memory is clear. No unexpected errors. Copy that. Endeavour OTC, close and lock your visors. Initiate O2 flow. Endeavour and work.
Go from main start. 8, 7, 6, 4, 3, 2, 0, and liftoff for the final launch of Endeavour. Expanding our knowledge while expanding our lives in space.
Houston, Endeavour, roll program. Roger, roll, Endeavour.
Houston is now controlling. Endeavour beginning to pull over onto its back. The roll program underway as Endeavour begins a heads-down position on course for a 51.6 degree, 136 by 36 statute mile orbit. Three engines now throttling down as Endeavour passes through the area of maximum dynamic pressure on the vehicle in the lower atmosphere. Approaching 1 minute into the flight.
Endeavour, go at throttle up. Roger, go at throttle up.
Endeavour's three main engines now back at full throttle, all three engines in good shape. Endeavour's already traveling 1,300 miles per hour at an altitude of 11 miles downrange from the Kennedy Space Center, now 12 miles. At liftoff, Endeavour fully fueled, weighed 4.5 million pounds. It's already lost half that weight in propellant now, burned that weight. Next event is burnout and separation of the twin solid rocket boosters. That upcoming here shortly at the 2 minute 3 second point. Those boosters are burning 11,000 pounds of fuel per second. And standing by for separation of the solid rocket boosters. The onboard guidance system has done its job of settling out any dispersions introduced at booster separation. The orbiter is now traveling 3,200 miles per hour, downrange 50 miles, altitude 37 miles. All systems in good shape. 3 good hydraulic systems, auxiliary power units, and fuel cells. The fuel cells providing electrical power to all of the systems.
Roger, 2 engine TAL.
Endeavour can reach a TAL site in the event of a single engine failure. However, all 3 are in good shape. Space Shuttle Endeavour sailing into fair winds on its final historic voyage. This view looking down the external fuel tank, the orbiter there on the top, as Endeavour continues to power its way into orbit, traveling 4,000 miles per hour, downrange 90 miles, altitude 50 miles. 3 minutes, 15 seconds into the flight. All 3 main engines still looking in good shape. Hydraulic systems and electrical systems on board the orbiter.
Endeavour, negative return.
Roger, negative return.
Endeavour can no longer return to the Kennedy Space Center in the event of an engine failure now, but all 3 are still in good shape, as are all of the other systems aboard the orbiter. Quiet here in Mission Control as a team of flight controllers watches over all of the systems. 4 minutes, 20 seconds into the flight, Endeavour's traveling 5,500 miles per hour. Altitude now 63 miles, traveling downrange 186 miles, or about 335,000 feet in altitude. Environmental and Control Systems Officer here reporting a good flash evaporator system providing cooling to all of the avionics equipment aboard the vehicle. Traveling into space on the forward flight deck is Commander Mark Kelly and pilot Greg Johnson. Between and behind them is flight engineer Roberto Vittori. And rounding out the flight deck crew is Mike Fink.
Endeavour, press to ATO.
Roger, press to ATO.
Endeavour can reach orbit on 2 engines should one fail at this point. However, all 3 are still performing as planned. Down on the middeck of Endeavour, Drew Feustel and Greg Chamitoff. Feustel headed to the International Space Station for the first time. Vittori and Fink making their first voyage on the Space Shuttle after flying to the International Space Station aboard Soyuz spacecraft previously.
Endeavour, single engine, Ops 3.
Roger, single engine Ops 3.
That call indicates that Endeavour could reach a transatlantic abort site on 1 engine if it lost 2 of the 3, although all 3 are still in good shape. 5 minutes, 50 seconds into the flight.
Endeavour, press to MECO and single engine Zaragoza, 104.
Roger, press to MECO, single engine Zaragoza, 104.
Several calls there. Endeavour can reach a safe orbit on 2 engines now. The guidance system is controlling the engines to roll Endeavour to a heads-up position to optimize the air-to-ground communications through the satellite network. Flight controllers reporting to Flight Director Richard Jones they're in good shape.
Your shutdown plan is nominal.
Copy. Shutdown plan is nominal.
For Mark, your go the plus X, go the pitch.
Roger, go for the plus X, go for the pitch.
Endeavour, single engine press, 104.
Roger, single engine press, 104.
Endeavour can reach orbit on 1 engine should 2 fail. However, all 3 are still in good shape. The 3 main engines are flowing fuel through their power systems at a rate equivalent to draining an average backyard swimming pool in 25 seconds. 7 minutes, 20 seconds into the flight. altitude 64 miles downrange from the Kennedy Space Center, 630 miles. Endeavour is traveling 13,500 miles per hour. We're now seeing throttling on the 3 main engines to maintain the 3G or 3 times gravity load on the vehicle and the crew. Engines at 82% of rated thrust, 8 minutes into the flight. The next activity is a main engine cutoff. That's expected to be commanded at 21 seconds. And main engine cutoff has been confirmed. Flight Dynamics reporting a nominal main engine cutoff. And separation from the external tank. Endeavour's Commander Mark Kelly now firing the thruster jets to position the orbiter for photography of the external tank.
We did see a nominal MECO. OMS 1 is not required.
Copy. Nominal MECO. OMS 1 not required. Hey, Mike, it's Greg. Good to hear your voice, and I'm ready to downlink MPC.
Greg, we're ready for that. We've about 4 minutes left, and it's good to hear your voice as well. Congratulations.
Thanks, man. Okay, it's coming now. There's about 5 minutes. I see 4 lights on my MPC player, so hopefully you're getting it.
Pilot Greg Johnson reporting that you're about to begin sending down some of the video the crew recorded today.
We got it, Greg. We got it up on a big screen. Looks great.
Excellent.
Right. Next thing is, a little bit ago I told Mark that there was a maneuver planned while you guys were sleeping. That was going to be controlled from the ground. I told him we weren't going to do that. And now apparently we might do that. We're not really sure. So you might be maneuvering this evening while you're sleeping. We're going to control that from the ground. There's no action for you. But just if you saw something happening, we don't want you to be surprised. So we're not sure. You may or may not have a maneuver control from the ground this evening.
Okay, Matt, we got that.
And then, finally, we have some words from your families. They wanted us to let you know that they had a great time at the launch. It was a great launch. It was very, very nice. They appreciate everything you did for them and wish you all the best of luck in your flight. They had a great time, and they'll be coming back home soon.
Well, that's fantastic, Matt. Thanks for the kind and thoughtful words. We wish them all the best as well and a safe return back, and we're happy that our friends and family were all there to see us launch off into the sunrise there.
Copy. We'll do that. You guys have a good evening and a great flight.
Thanks.
On the big screen, and we've got about another minute and a half, and then maybe we can pick it up another time.
Okay, sounds
Hey, Drew.
Hey, Taz.
There you are.
Yeah, thanks.
Back in space.
We're back in black, buddy. It's nice to be back. That was one heck of a ride.
Yeah, it was awesome.
Fantastic, and it's good to be here. We're just getting reconfigured here for the cameras, and we're gonna get busy.
All right.
Now it's recording. Okay. You ready for the almost 2 burn, Taz?
Ready for the almost 2 burn.
Are you sure? I'm not sure I am.
I'm still getting used to this again. Okay, Ohms burn starting in 5 seconds.
About now.
Here we go.
Here we go.
That's a real burn.
It's a long burn. We can do that again.
You're right.
There it goes.
Yeah, that's like a 1/10 of a G.
Where's your other boot, by the way?
It's tied off.
Hey, we're trying to work down here.
That's a good. That's a good. These 1/10 of a G. Wow.
Wow. Okay, let's keep on everything. All right.
Enough playing around. Let's get to work.
Where's the other boot?
Ready?
Okay, we're going to open the payload bay doors now.
We lost the close indication as expected. 10 seconds. About 20 seconds we should see the open for the central latches. Yes. Now we go to the next block.
The next block.
Another 20 seconds. Stand by. Another 9 seconds. Yeah.
I see, good. Now the forward and aft latches.
Yeah.
So far, so good, Mark.
All right.
1:10 is the time. Another 15 seconds, vantage. And you always keep track of the big switch, right?
Yes, I have my eyeballs on it and my fingers can get to it. There we go. Start of payload bay door opening.
Payload bay door is ongoing.
It looks like a dual motor time. There's the sunshine. Waiting for the door indication.
2:13.
Door is open. The port side. The forward and aft latches are going. I see a small piece of FOD. It's a washer. Floating right above ELC3. Another one in the back. I see two washers. One's a washer. I'm trying to get a good tally on it with the camera. Payload bay door is opening. Got a small other miscellaneous things. Payload bay door opening is looking very solid. There's the washer. Mark, that's about a 1/2 inch washer. All right, I see them all open also. And it looked good outside.
I'll come over.
We're rolling.
All right, here we are in the flight deck of Endeavour, flight day 1. Recently in space. Sorry about the cloud deck.
when we took off.
We're really excited. It's great to be up here.
Yeah, it was a spectacular ride. I couldn't see anything but the lockers, but it was still a lot of fun.
No master alarms.
I'll have to say it was a lot different than flying on the Soyuz.
Ready for the left dome's accumulator.
And back to work.
Go ahead.
Hey guys, here we are, Roberto and I. We're on the mid-deck. We're setting up GIRA, which is our water purification system over here. And we've been in space now for what, 4 hours, 5 hours, something like that. And amazingly, we're all feeling great. This is awesome. I can't wait to get back to the space station and feeling just awesome. Roberto?
My first ride on the shuttle was an amazing launch, and then Miko. I was a little afraid, but got quickly adapted. And it's very interesting to work with old shuttle systems. And I need to say that it's easier here in microgravity than was during the training floor. Most of the equipment here just makes sense. It is very intuitive, and happy to be here.
And it was a great ride up. It was an awesome flight up. As excited as we were being on top of the rocket. That was great.
You are in camera.
You're upside down.
Hey, didn't I see you up here last time? You were upside down last time too.
You're still upside down.
Oh, you're upside down.
This is Mission Control Houston. That completes our video highlights from the day. 34 minutes of the best video from the STS-134 cruise preparations and launch from the Kennedy Space Center in Florida. Again, launch at 7:56 a.m. Central Time this morning. Went exactly according to plan. The Space Shuttle Endeavour doing very well as it chases the International Space Station at a speed of 17,500 miles an hour. Now tracking directly over the Isthmus of Panama and the connection between Central America and South America on a southeasterly course. Space station is approximately 1,700 statute miles ahead of the space shuttle, and the shuttle is catching up by about 100 miles every orbit of the planet. This is Mission Control Houston. We are receiving some live downlink television pictures from the external cameras on the International Space Station as the STS-134 crew aboard the space station is sleeping right now. Aboard the Space Shuttle Endeavour is sleeping right now. This is a view of a sunset as the Space Shuttle passes from daylight into darkness over the South American continent on a southeasterly track. Space Station Expedition 27 crew also in a sleep mode right now as they rest up and get ready for a very busy 2 weeks of operations in support of the STS-134 mission. Again, Endeavour making its 25th and final flight. This space station mission delivering the Alpha Magnetic Spectrometer, a large pallet full of spare parts for the outside of the space station, and will include 4 different spacewalks, among them servicing of the solar alpha rotary joint that allows the solar rays to rotate and track the sun and generate the electricity that both the station and the Alpha Magnetic Spectrometer will need to conduct their operations in orbit. We also received some photographs from today's launch activities. This is part of our STS-134 photo gallery, some of the best pictures of the day. This particular shot shows Richard Jones on the left, viewing data at the flight director's console in the Space Shuttle Flight Control Room here. Christopher Seacraft Mission Control Center, as preparations are underway in Florida for the launch of Space Shuttle Endeavour. He's with astronaut Barry Wilmore, also known as Butch, who serves as the Capcom or spacecraft communicator for the mission. during the ascent segment. Of course, Endeavour lifted off from Kennedy Space Center at 7:56 a.m. Central Time today. The next picture is of the crew walkout after shooting up. The STS-134 crew members paused alongside their Astrovan to wait for farewell to onlookers before they headed out to the launch pad and climbed into their seats for the liftoff. And then, of course, the American flag. Or in this case, the Space Shuttle Endeavour on the launch pad, awaiting liftoff on this 25th and final flight. And here is the U.S. flag waving at the launch site as Endeavour lifts off from the pad, just 6 seconds after liftoff. And those are our pictures of the day for the STS-134 mission. This is Mission Control Houston. All systems working well on Endeavour as the Space Shuttle crew continues its sleep shift. Commander Mark Kelly, along with pilot Greg Johnson and Mission Specialist Roberto Vittori of the European Space Agency, and Mike Fink, Drew Feustel, and Greg Shamatov of NASA, all getting some well-deserved rest after a busy day of preparations and launch from the Kennedy Space Center in Florida. Again, launch occurred of Endeavour's space mission this morning at 7:56 a.m. Central Time. The Space Shuttle is performing very well as it orbits the planet, chasing the International Space Station at 17,500 miles an hour, where the Expedition 27 crew of Commander Dmitry Kondrachev and flight engineers Paolo Nespoli, Katie Coleman, Andrei Borisenko, Alexander Samokotayev, and Ron Guerin are all also in their sleep shift as the two crews get rest for the preparations for the very busy 2-week mission to install the Alpha Magnetic Spectrometer, a new platform of spare parts, and to conduct a number of servicing activities associated with the mission. We're coming up on the top of the hour, which will be our first replay of the Flight Day 1 highlights package, all 34 minutes of the best video of today's launch preparations and launch video, coming up at 6 p.m. Central Time, 7 p.m. Eastern, at the Christopher C. Kraft Jr. Mission Control Center in Houston.
Hi, I'm Mark Kelly, commander of STS-134, and you're watching NASA TV.
Endeavour will also bring up to the station the Express Logistics Carrier 3, an external platform for the space station that holds large equipment that will carry spare parts and equipment to sustain the space station's operation in space once the last space shuttle flight has occurred this summer. There are 4 planned EVAs, or spacewalks, outside the International Space Station during the STS-134 mission to do maintenance and install new components. And here is Commander Mark Kelly, our 134 mission commander, making his 4th flight on the space shuttle. He's logged a total of 38 days in space. His latest flight was in 2008 on STS-124. Going over to our pilot now, Greg Johnson. He's making his 2nd space flight, previously also piloted on STS-123 in 2008. He's logged over 4,000 hours in 40 different types of aircraft. This is Mike Fink, Mission Specialist number 1. This is his 3rd space flight, but his 1st space shuttle flight. He was launched previously from Russia on Soyuz spacecraft, and he's logged 365 days in space with over 26 hours on 6 spacewalks. Mission Specialist Greg Shamatov. This is his 2nd space flight, but he's already logged 183 days in space aboard the space station. He's Canadian-born from Montreal. And there's Drew Feustel, Mission Specialist number 3, making his 2nd trip into space. He served as An astronaut for more than a decade, working on both the Space Shuttle and the space station branches in Houston. He flew on the 5th and final HST servicing mission. And Roberto Vittori. He's mission specialist number 2. He was selected as an astronaut by the European Space Agency. He's from Viterbo, Italy. And he has flown to the International Space Station twice. And here come our astronauts, leaving the suit-up room bound for the elevator that will take them down to the astronaut van, the Astrovan. This is the same elevator that all astronauts since Apollo have used to leave the crew quarters and go out to the launch pad. It's about a 20-minute ride from the astronaut quarters out to the launch pad, covering about 10 miles, and they allow another 10 minutes or so for the crew to get off the Astrovan and look around a little bit and head up the fixed service structure and then begin boarding the space shuttle. So that allows for about a half an hour for the entire process from the time they leave the astronaut quarters until they start boarding. And there they go.
WCC, they're at the pad.
And the astronaut van now on the pad surface. Crew taking a moment to look at Space Shuttle Endeavour, something that most crews like to do before they head up to board the spaceship.
And OTC, OVCC.
OVCC, OTC, go.
Flight crew has arrived at the orbiter. Crew ingress and work at this time.
See that.
Drew Feustel is up next. He's mission specialist number 3, making his second trip into space. He's served more than a decade as a NASA astronaut, working on both the space shuttle and the space station branches. Greg Johnson, he's about to board.
OTC, OVCC.
VCC, OTC.
MS3 on board at this time.
0940.
This is a live shot from the mid-deck area. This is Mission Specialist number 4, Greg Shamatov. STS-134 is his second space flight, but he's already logged 183 days in space aboard the International Space Station.
OTC, CDR, check. CDR, this is OTC. I have you loud and clear. Good morning, Mark.
Hey, good morning. How are you?
Very good. And CMQC 65.
Roberto Fattori and Mike Fink waiting to enter the White Room.
And CGSS OTC.
OTC, CGLS.
CLS OTC.
Yes, sir. I can give you steps 592 through 598. We've completed implementation of step 92.
Copy that. Thank you.
Greg Shamatov now on board. He's going to be sitting in the mid-deck center seat, joining Drew Feustel on the mid-deck. This is astronaut Mike Fink. He's Mission Specialist number 1. This is his third space flight, but his first space shuttle flight. He's logged over 365 days in space, with over 26 hours on 6 spacewalks on the International Space Station on expeditions 9 and 18.
OTC, TLT, check. TLT, OTC, I have you loud and clear. Good morning, box.
Good morning, Mark.
Your checklist.
Copy that.
And CMQC 690, 692 are complete as well.
This is Roberto Fattori, our Mission Specialist number 2. He was selected as an astronaut by the European Space Agency and is from Viterbo, Italy. And he has flown to the International Space Station on 2 past occasions.
OTC, MS4, check.
MS4, OTC, I have you loud and clear. Welcome aboard, Greg.
Thanks, Mark. Also have you loud and clear.
OTC, CWS.
Double F, go.
I can verify step 685.
Thank you.
And Roberto Vittori now climbing on board Endeavour.
And OTC, OVCC.
Mission Specialist number 2.
MS2 on board at this time, and that is all crew members on board.
So all of the crew members are now on board.
Please pass that to fire rescue leader.
Copy that.
And NTD, your polls go. Is that affirmative?
That is affirmative. We are all go.
Okay, copy that. KC Chief Processing Engineer, verify no constraints to launch.
No constraints.
Thank you, Steve. KC Safety and Mission Assurance.
KC Safety and Mission Assurances, go.
Thank you, Dave. Payload Launch Manager.
Mike, Space Station Processing Teams, go.
Thank you, Bill. Range Weather.
Weather has no constraints to launch.
Thank you, Kathy. And Ops Manager.
Mike, things look real good today. Thanks to your team for getting us back here. You're good. Launch Endeavour.
Good. Thank you, sir. Endeavour Launch Director, Air to Ground 1. Okay, Mark, looks like a great day to launch Endeavour for the final time. So on behalf of the thousands of proud Americans who have been part of her journey, good luck, Godspeed, and we'll see you back here June 1st.
Thank you, sir. On this final flight of Space Shuttle Endeavour, we want to thank all the tens of thousands of dedicated employees that have put their hands on this incredible ship and dedicated their lives to the Space Shuttle program. As Americans, we endeavor to build a better life than the generation before, and we endeavor to be a united nation. In these efforts, we are often tested. This mission represents the power of teamwork, commitment, and exploration. It is in the DNA of our great country to reach for the stars and explore. We must not stop. To all of the millions watching today, including our spouses, children, family, and friends, we thank you for your support. Endeavour OTC, it's your final voyage. This is both a sad and proud moment for your launch team and for America, but your legacy will live on. Mission success with AMS, a truly international effort. Godspeed, and see you back in a couple of weeks. Endeavour copies. Thanks for the words. Appreciate it. OTC, PLT, caution and warning memory is clear. No unexpected errors. Copy that. Endeavour OTC, close and lock your visors. Initiate O2 flow. Endeavour and work.
Go from main start. 8, 7, 6, 4, 3, 2, 0, and liftoff for the final launch of Endeavour, expanding our knowledge, expanding our lives in space.
Houston, Endeavour, roll program.
Roger, roll, Endeavour.
Houston is now controlling. Endeavour beginning to pull over onto its back. The roll program underway as Endeavour begins a heads-down position on course for a 51.6 degree, 136 by 36 statute mile orbit. Three engines now throttling down as Endeavour passes through the area of maximum dynamic pressure on the vehicle in the lower atmosphere. Approaching 1 minute into the flight.
Endeavour, go at throttle up.
Roger, go at throttle up.
Endeavour's three main engines now back at full throttle, all three engines in good shape. Endeavour's already traveling 1,300 miles per hour at an altitude of 11 miles downrange from the Kennedy Space Center, now 12 miles. At liftoff, Endeavour fully fueled, weighed 4.5 million pounds. It's already lost half that weight in propellant now, burned that weight. Next event is burnout and separation of the twin solid rocket boosters. That upcoming here shortly at the 2 minute 3 second point. Those boosters are burning 11,000 pounds of fuel per second. And standing by for separation of the solid rocket boosters. The onboard guidance system has done its job of settling out any dispersions introduced at booster separation. The orbiter is now traveling 3,200 miles per hour, downrange 50 miles, altitude 37 miles. All systems in good shape. 3 good hydraulic systems, auxiliary power units, and fuel cells. The fuel cells providing electrical power to all of the systems.
Roger, 2 engine TAL.
Endeavour can reach a TAL site in the event of a single engine failure. However, all 3 are in good shape. Space Shuttle Endeavour sailing into fair winds on its final historic voyage. This view looking down the external fuel tank, the orbiter there on the top, as Endeavour continues to power its way into orbit, traveling 4,000 miles per hour, downrange 90 miles, altitude 50 miles. 3 minutes, 15 seconds into the flight. All 3 main engines still looking in good shape. Hydraulic systems and electrical systems on board the orbiter.
Endeavour, negative return.
Roger, negative return.
Endeavour can no longer return to the Kennedy Space Center in the event of an engine failure now, but all 3 are still in good shape, as are all of the other systems aboard the orbiter. Quiet here in Mission Control as a team of flight controllers watches over all of the systems. 4 minutes, 20 seconds into the flight, Endeavour's traveling 5,500 miles per hour. Altitude now 63 miles, traveling downrange 186 miles, or about 335,000 feet in altitude. Environmental and Control Systems Officer here reporting a good flash evaporator system providing cooling to all of the avionics equipment aboard the vehicle. Traveling into space on the forward flight deck is Commander Mark Kelly and pilot Greg Johnson. Between and behind them is flight engineer Roberto Vittori. And rounding out the flight deck crew is Mike Fink.
Endeavour, press to ATO.
Roger, press to ATO.
Endeavour can reach orbit on 2 engines should one fail at this point. However, all 3 are still performing as planned. Down on the middeck of Endeavour, Drew Feustel and Greg Chamitoff. Feustel headed to the International Space Station for the first time. Vittori and Fink making their first voyage on the Space Shuttle after flying to the International Space Station aboard Soyuz spacecraft previously.
Endeavour, single engine, Ops 3.
Roger, single engine Ops 3.
That call indicates that Endeavour could reach a transatlantic abort site on 1 engine if it lost 2 of the 3, although all 3 are still in good shape. 5 minutes, 50 seconds into the flight.
Endeavour, press to MECO and single engine, Zaragoza, 104.
Roger, press to MECO, single engine, Zaragoza 104.
Several calls there. Endeavour can reach a safe orbit on 2 engines now. The guidance system is controlling the engines to roll Endeavour to a heads-up position to optimize the air-to-ground communications through the satellite network. Flight controllers reporting to Flight Director Richard Jones they're in good shape.
Your shutdown plan is nominal.
Copy, shutdown plan is nominal.
For Mark, your go the plus X, go the pitch.
Roger, go for the plus X, go for the pitch.
Endeavour, single engine press, 104.
Roger, single engine press, 104.
Endeavour can reach orbit on 1 engine should 2 fail. However, all 3 are still in good shape. The 3 main engines are flowing fuel through their power systems at a rate equivalent to draining an average backyard swimming pool in 25 seconds. 7 minutes, 20 seconds into the flight. altitude 64 miles downrange from the Kennedy Space Center, 630 miles. Endeavour is traveling 13,500 miles per hour. We're now seeing throttling on the three main engines to maintain the 3G or 3 times gravity load on the vehicle and the crew. Engines at 82% of rated thrust, 8 minutes into the flight. The next activity is main engine cutoff. That's expected to be commanded at 21 seconds. And main engine cutoff has been confirmed. Flight Dynamics reporting a nominal main engine cutoff. And separation from the external tank. Endeavour's Commander Mark Kelly now firing the thruster jets to position the orbiter for photography of the external tank.
We did see a nominal MECO. OMS 1 is not required.
Copy. Nominal MECO. OMS 1 not required. Hey, Mike, it's Greg. Good to hear your voice, and I'm ready to downlink MPC.
No.
Greg, we're ready for that. We've about 4 minutes left, and it's good to hear your voice as well. Congratulations.
Thanks, man. Okay, it's coming now. I see 4 lights on my MPC player, so hopefully you're getting it.
Pilot Greg Johnson reporting that you're about to begin sending down some of the video the crew recorded today.
We got it, Greg. We got it up on a big screen. Looks great.
Excellent.
Right, next thing is, a little bit ago I told Mark that there was a maneuver planned while you guys were sleeping. I was going to be controlled from the ground. I told him we weren't going to do that. And now, apparently, we might do that. We're not really sure. So you might be maneuvering this evening while you're sleeping. We can control that from the ground. There's no action for you. But just if you saw something happening, we don't want you to be surprised. So we're not sure. You may or may not have a maneuver control from the ground this evening.
Okay, Matt, we got that.
And then, finally, we have some words from your families. They wanted us to let you know that they had a great time at the launch. It was a great launch. It was very, very nice. They appreciate everything you did for them and wish you all the best of luck in your flight. They had a great time, and they'll be coming back home soon.
Well, that's fantastic, Matt. Thanks for the kind and thoughtful words. We wish them all the best as well and a safe return back, and we're happy that our friends and family were all there to see us launch off into the sunrise there.
Copy. We'll do that. You guys have a good evening and a great flight.
Thanks.
On the big screen, and we've got about another minute and a half, and then maybe we can pick it up another time.
Okay, sounds
Hey, Drew.
Hey, Dad.
There you are.
Yeah, thanks.
Back in space.
We're back in black, buddy. It's nice to be back. It was one heck of a ride.
Yeah, it was awesome.
Fantastic, and it's good to be here. We're just getting reconfigured here for the cameras, and we're gonna get busy.
All right.
Now it's recording.
Okay.
You ready for the Ohms 2 burn, Taz?
Ready for the Ohms 2 burn.
Are you sure? I'm not sure I am.
I'm still getting used to this again. Okay, Ohms burn starting in 5 seconds.
About now.
Here we go. Here we go. Whoa! That's a real burn.
It's a long burn. We can do that again.
You're right.
There it goes.
Yeah, that's like a tenth of a G.
Where's your other boot, by the way?
It's tied off.
Hey, we're trying to work down here.
That's a good. That's a good. These tenth of a G. Wow.
Wow. Okay, let's see what everything. All right.
Enough playing around. Let's get to work.
Where's the other boot?
Ready? Okay, we're going to open the payload bay doors now.
We lost the close indication as expected. 10 seconds. About 20 seconds we should see the open for the simple latches. Yes. Now we go to the next block.
The next block.
Another 20 seconds. Stand by. Another 9 seconds. Yeah.
I see, good. Now the forward and aft latches.
Yeah.
So far, so good, Mark.
All right.
110 is the time. As you expect. Another 15 seconds, vanquish. And you always keep track of the big switch, right?
Yes, I have my eyeballs on it and my fingers can get to it. There we go. Start of payload bay door opening.
Payload bay door is ongoing.
It looks like a dual motor time. There's the sunshine. Waiting for the door indication.
213.
Door is open. The port side. The forward and aft latches are going. I see a small piece of FOD. It's a washer. Floating right above ELC3. Another one in the back. I see two washers. One's a washer. I'm trying to get a good tally on it with the camera. Payload bay door is opening. Got a small other miscellaneous things. Payload bay door opening is looking very solid. There's the washer. Mark, that's about a half-inch washer. All right, I see them all open also, and it looked good outside.
I'll come over.
We're rolling.
All right, here we are in the flight deck of Endeavour, flight day 1. Recently in space. Sorry about the cloud deck.
when we took off.
We're really excited. It's great to be up here.
Yeah, it was a spectacular ride. I couldn't see anything but the lockers, but it was still a lot of fun.
No master alarms.
I'll have to say it was a lot different than flying on the Soyuz.
For the left dome accumulator.
And back to work.
Go ahead.
Hey guys, here we are, Roberto and I. We're on the mid-deck. We're setting up JIRA, which is our water purification system over here. And we've been in space now for what, 4 hours, 5 hours, something like that. And amazingly, we're all feeling great. It's this is awesome. I can't wait to get back to the space station, and feeling just awesome. Roberto?
My first ride on the shuttle was amazing launch, and then Miko. I was a little afraid, but got quickly adapted, and it's very interesting to work with old shuttle systems. And I need to say that it's easier here in microgravity than was during the training floor. Most of the equipment here just makes sense. It is very intuitive, and happy to be here.
And it was a great ride up. It was an awesome flight up. As excited as we were being on top of the rocket. That was great.
You are in camera.
You're upside down.
Hey, didn't I see you up here last time? You were upside down last time too.
You're still upside down.
Oh, you're upside down.
This is Mission Control Houston, back now with live coverage of the activities here at the Christopher C. Kraft Jr. Mission Control Center, where Flight Director Quatziala Barujo, along with spacecraft communicator Shannon Lucid, sit side by side on console, monitoring the status of systems on board the Space Shuttle Endeavour, where its crew, Commander Mark Kelly, pilot Greg Johnson, and Mission Specialist Greg Shamatov, Drew Feustel, Mike Fink, and Roberto Vittori of the European Space Agency are in a sleep shift that is scheduled to end around 11 p.m. Central Time, midnight Eastern. Shuttle and station are chasing one another over the Earth's surface. Now orbiting over eastern China is where the Space Shuttle is located. The International Space Station about 1,700 miles ahead, with the gap between the two spacecraft widening by approximately 90 nautical miles or 100 statute miles per trip around the world. All systems on Endeavour working very well following today's launch from the Kennedy Space Center in Florida. Of course, that launch taking place at 7:56 a.m. Central Time, 8:56 a.m. Eastern. The crew of the International Space Station, which will soon be joining forces with the Endeavour crew, also in its sleep shift. They went to bed about 4:30 p.m. Central Time. Commander Dmitry Kondratyev and flight engineers Pablo Nespoli, Katie Coleman, Andrei Borisenko, Alexander Samakudyayev, and Ron Guerin are in their sleep shift. We are receiving some live downlink television pictures from the external cameras on the International Space Station as it passes over the Korean Peninsula and Japan. Both the International Space Station and the Space Shuttle traveling on a northeasterly course that will soon take them over the northern Pacific Ocean and on this particular orbit just off the western coast of the United States. This is Mission Control Houston, continuing to watch live television pictures of the Earth below as the International Space Station tracks over the western coast of the United States, just out over the Pacific Ocean, as it passes off the western coast of California. Some weather systems clearly visible in these views from on board the International Space Station, where Commander Dmitry Kondrachev and flight engineers Katie Coleman, Ron Guerin, Paolo Nespoli, Alexander Samokotyaev, and Andrei Borisenko continue to orbit the planet as they await the arrival of the STS-134 crew of the Space Shuttle Endeavour, which lifted off from the Kennedy Space Center in Florida this morning. All systems on the shuttle working very well as Commander Mark Kelly, pilot Greg Johnson, and mission specialist Mike Fink, Drew Feustel, Greg Shamatov, and the European Space Agency's Roberto Vittori get some much-needed rest after a very busy day of preparations on launch from Kennedy. They are trailing the International Space Station by a little bit less than 2,000 miles now, catching up by approximately 100 statute miles every orbit of the Earth. Space Shuttle Endeavour crew scheduled to be awakened at 10:56 p.m. Central Time, 11:56 p.m. Eastern. And the International Space Station crew scheduled to awaken as usual about 1 a.m. Central Time, 2 Eastern, as they begin their day of preparations for the arrival of the space station. Tomorrow's activities aboard Space Shuttle Endeavour will focus primarily on scanning the heat protection systems on the space shuttle to make sure they weren't damaged during the climb into orbit. Among the activities will be the unberthing of the orbiter boom sensor system, which is scheduled to begin about 1:26 a.m. Central Time. And then the crew on board the Space Shuttle Endeavour will use the robotic arm, known as Canadarm, to survey the reinforced carbon-carbon on the leading edges of the wings and on the nose cap of the space shuttle. Crew also will begin initial checkout of the extravehicular mobility units, or EMUs, which are the spacesuits that the spacewalkers on board the space shuttle will use. Spacewalkers on this flight include Drew Feustel and Greg Shamatov, who will be doing EVA number 1. Feustel and Mike Fink will be performing EVA number 2. Feustel and Fink, who also will be performing EVA number 3. And then it'll be back to Mike Fink and Greg Shamatov for the 4th and final planned spacewalk of the mission. In addition to the spacesuit checkouts, the crews also will be doing centerline camera installation and rendezvous tool checkout to make sure that they're ready to dock with the International Space Station. And they'll be doing a survey of the orbital maneuvering system pods using the camera on the end of Canadarm to take a look at the tile systems on the aft section of the space shuttle. Again, all that part of the normal activities on this first full day of operations aboard the space shuttle. A reminder that coming up next on NASA TV will be our replay of the Flight Day 1 highlights package coming up at the top of the hour. Again, today's package is about 34 minutes long. Here in the Space Shuttle Flight Control Room, the Orbit 3 or planning shift team of flight controllers continues to watch over systems aboard the shuttle. Quatziela Barujo is the space flight director in charge of the team, with Shannon Lucid, the astronaut who will be setting up the wake-up greetings to the crew when they awaken about 11 p.m. Central Time. Meanwhile, on the space station side of the building, the flight control team there is being led by Flight Director Dina Cantella. with astronaut Dan Tani, available to talk to the space station crew. Both sides of the Mission Control Center station and shuttle working on planning activities as they get ready for a busy day tomorrow. Again, our next event on NASA TV coming up in about a minute and a half at the top of the hour with a 7 p.m. Central Time, 8 p.m. Eastern Time replay of the Flight Day 1 highlights package. This is Mission Control Houston.
Hi, I'm Mark Kelly, commander of STS-134, and you're watching NASA TV.
Endeavour will also bring up to the station the Express Logistics Carrier 3, an external platform for the space station that holds large equipment that will carry spare parts and equipment to sustain the space station's operation in space once the last space shuttle flight has occurred this summer. There are 4 planned EVAs, or spacewalks, outside the International Space Station during the STS-134 mission to do maintenance and install new components. And here is Commander Mark Kelly, our 134 mission commander, making his 4th flight on the space shuttle. He's logged a total of 38 days in space. His latest flight was in 2008 on STS-124. Going over to our pilot now, Greg Johnson. He's making his 2nd space flight, previously also piloted on STS-123 in 2008. He's logged over 4,000 hours in 40 different type of aircraft. This is Mike Fink, mission specialist number 1. This is his 3rd space flight, but his 1st space shuttle flight. He was launched previously from Russia on Soyuz spacecraft, and he's logged 365 days in space with over 26 hours on 6 spacewalks. Mission specialist Greg Shamatoff. This is his 2nd space flight, but he's already logged 183 days in space aboard the space station. He's Canadian-born from Montreal. And there's Drew Feustel, mission specialist number 3, making his 2nd trip into space. He served as an astronaut for more than a decade, working on both the space shuttle and the space station branches in Houston. He flew on the 5th and final HST servicing mission. And Roberto Vittori. He's mission specialist number 2. He was selected as an astronaut by the European Space Agency. He's from Viterbo, Italy. And he has flown to the International Space Station twice. And here come our astronauts, leaving the suit-up room bound for the elevator that will take them down to the astronaut van, the Astrovan. This is the same elevator that all astronauts since Apollo have used to leave their crew quarters and go out to the launch pad. It's about a 20-minute ride from the astronaut quarters out to the launch pad, covering about 10 miles, and they allow another 10 minutes or so for the crew to get off the Astrovan and look around a little bit and head up the fixed service structure and then begin boarding the space shuttle. So that allows for about a half an hour for the entire process from the time they leave the astronaut quarters until they start boarding. And there they go.
WCC, they're at the pad.
And the astronaut van now on the pad surface. Crew taking a moment to look at Space Shuttle Endeavour, something that most crews like to do before they head up to board the spaceship.
And OTC, OVCC.
OVCC, OTC, go.
My crew has arrived at the orbiter. Crew ingress and work at this time.
See that?
Drew Feustel is up next. He's mission specialist number 3, making his second trip into space. He's served more than a decade as a NASA astronaut, working on both the space shuttle and the space station branches. And Greg Johnson, he's about to board.
OTC, OVCC.
OVCC, OTC.
MS3 on board at this time.
0940.
a live shot from the mid-deck area. This is Mission Specialist number 4, Greg Shamatov. STS-134 is his second space flight, but he's already logged 183 days in space aboard the International Space Station.
OTC CDR, com check. CDR, this is OTC. I have you loud and clear. Good morning, Mark. Hey, good morning. How are you? Very good. It's CTC 65.
Roberto Fattori and Mike Fink waiting to enter the White Room.
And CGSS OTC.
OTC CGLS.
CLS OTC.
Yes, sir. I can give you steps 592 through 598. We've completed implementation of step 92.
Copy that. Thank you.
Greg Shamatov now on board. He's going to be sitting in the mid-deck center seat, joining Drew Feustel on the mid-deck. This is astronaut Mike Fink. He's mission specialist number 1. This is his third space flight, but his first space shuttle flight. He's logged over 365 days in space, with over 26 hours on 6 spacewalks on the International Space Station on expeditions 9 and 18.
OTC, TLT, com check. TLT, OTC, I have you loud and clear. Good morning, Box. Good morning, Mark. Your checklist. Copy that. And CMQC 690, 692 are complete as well.
This is Roberto Fattori, our mission specialist number 2. He was selected as an astronaut by the European Space Agency and is from Viterbo, Italy. And he has flown to the International Space Station on 2 past occasions.
OTC, MS4, com check. MS4, OTC, I have you loud and clear. Welcome aboard, Greg. Thanks, Mark. Also have you loud and clear.
OTC CWS.
Double F, go.
I can verify step 685.
Thank you.
And Roberto Vittori now climbing on board Endeavour.
And OTC, OVCC.
Mission specialist number 2.
MS2 on board at this time, and that is all crew members on board.
So all of the crew members are now on board.
Please pass that to Fire Rescue Leader.
Copy that.
And NTD, your polls go. Is that affirmative?
That is affirmative. We are all go.
Okay, copy that. KC Chief Processing Engineer, verify no constraints to launch.
No constraints.
Thank you, Steve. KC Safety and Mission Assurance.
KC Safety and Mission Assurances, go.
Thank you, Dave. Payload Launch Manager.
Mike, Space Station Processing Team, go.
Thank you, Bill. Range Weather.
Weather has no constraints to launch.
Thank you, Kathy. And Ops Manager.
Mike, things look real good today. Thanks to your team for getting us back here. You're good. Launch Endeavour.
Good. Thank you, sir. Endeavour Launch Director, Air to Ground 1. Okay, Mark, looks like a great day to launch Endeavour for the final time. So on behalf of the thousands of proud Americans who have been part of her journey, good luck, Godspeed, and we'll see you back here June 1st.
Thank you, sir. On this final flight of Space Shuttle Endeavour, we want to thank all the tens of thousands of dedicated employees that have put their hands on this incredible ship and dedicated their lives to the Space Shuttle program. As Americans, we endeavor to build a better life than the generation before, and we endeavor to be a united nation. In these efforts, we are often tested. This mission represents the power of teamwork, commitment, and exploration. It is in the DNA of our great country to reach for the stars and explore. We must not stop. To all of the millions watching today, including our spouses, children, family, and friends, we thank you for your support.
Endeavour OTC, it's your final voyage. This is both a sad and proud moment for your launch team and for America, but your legacy will live on. Mission success with AMS.